Hello and good morning, good afternoon, good evening, wherever you are. My name is Mitchell Pearson here at Pragmatic Works, and welcome to another Learn with the Nerds event. Today we're going to be taking a look at T-SQL. T-SQL is pivotal. It's very important to our jobs for anybody who really works with data. And so we felt it was pertinent and important to go ahead and go through a 3-hour event live with you where we could do an event on SQL Server. All right, so let's jump right in and talk a little bit about myself. I'm the training manager here at Pragmatic Works. I've been here for about 9.5 years now. Started off in software, then consulting for a few years, and I've been working in training for about 4 years now, working with the training department. That role includes creating a lot of new classes for our on-demand learning platform, and then also teaching and doing classes like what we're doing here today. I've been fortunate to author a couple of different books on Power BI, SQL Server 2019 when that was released, and then also the Power Platform, Power BI, Power Apps, Power Automate. I blog at mitchellpearson.com. I have a wife and 3 kids here in Florida, inside of the United States, and I specify that because I see we have people from literally all over the world joining us here today. And then I enjoy playing tabletop games. So if you've ever played Ticket to Ride or Catan or something like that, those are things that I enjoy doing. Obviously, you found us through YouTube, so make sure to take a moment to click that like and subscribe button so that you get notified when we do future events in the future. All right, so what is the agenda today? We have 3 hours together. What are we going to cover? First of all, we're going to talk a little bit about what is SQL, right? What is SQL? What is it? Why is it important? We're going to take a look at the select clause and the from clause. We're going to look at how do we filter down those queries using the where clause. We're also going to take a look at something very important, which is using joins. The join allows us to combine multiple tables together. And then, of course, we're going to take a look at writing aggregate queries where we can return multiple aggregations like sum, min, max, etc. And we're going to do that right there within our SQL query language. The logistics for today is going to be Eastern time. It's going to be from 11 until 2 p.m. Eastern time. We will take a break around 12:15 Eastern time, 12:20, and we'll take a 15-minute break. That'll give you time to get up and kind of stretch your legs. And then also, there is a download that I've provided that has some information in it. It has pretty much all of the SQL scripts that I'm going to run today. It also has a PDF document that shows you how to connect to SQL Server Management Studio, and using the credentials that I'm using, how you can use SQL Server Management Studio to connect to an Azure SQL database if you want to try to follow along. The only thing that I would warn you if you say, hey, I think I'm going to try to follow along, just make sure you have a second monitor. Make sure you have kind of some familiarity with what we're working with today so you don't get frustrated, because there are going to be probably over 1,000 people in this live event, and there's just no way we're going to be able to stop and do any kind of troubleshooting. So the event will be recorded. You can go back and watch it at any time you want on YouTube after the fact, and you can go back through all of those scripts that I've given you. And if you run into problems, we can probably try to help you with that after the fact. Here's what you're going to get when you download those files. You're going to get essentially 2 things. You're going to get the SQL scripts folder right here that has all of the SQL scripts I'm going to be using today. And then we're also going to be connecting, or we're going to use this PDF right here that shows you how to use SSMS to connect to an Azure SQL database. Make sure to remember to put in the database name because I'm using database scoped credentials for this example. All right, so I'm going to move that back over there. Those are the files that you're going to want if you want to try to follow along at all at any point today. All right, SSMS is also a requirement. We sent that out in the email. SSMS is a free tool. You can go to aka.ms/SSMS and download that file. You can download it, you can install it, it's free, and then that will allow you to connect. You do want to be on one of the newer versions of it because on older versions, there's sometimes connectivity issues to certain things in Azure. So being on a newer version of SSMS is going to be very beneficial to you. There we go. All right, trying to watch the chat window a little bit over there as well. So let's jump right in. I have about 3 or 4 slides here, and then we're going to jump right into the demos. All right. So SQL databases. Why do we have SQL databases, right? What does it mean? A SQL database is a place that we can store and work with all of our organizational data, right? If you go way, way back, we used to store all of the data on files, on paper, in filing cabinets. That's obviously not the most effective way to store our information, and it's not the most effective way to retrieve that information. And so obviously, if you've ever worked with the data today, you've probably worked with a database in some form or some fashion. And the database gives us a way to not only store the data, but to keep it in an organized fashion based on whatever our requirement is, whether I'm trying to load data for my web application or whether I'm trying to report from that database for our reports and our dashboards and our machine learning, right? So that right there is what a database is. A database is an organized structure for our data. Now, if we have databases in our organization, in the cloud, wherever they might be, how do we get data into those databases, and then how do we get data out of those databases? We do that using the structured query language, which is SQL, or some people call it SQL. I mostly say SQL myself, but it's the structured query language. We use the structured query language to communicate with our databases, to insert data in, retrieve data from it, and also edit existing data. Who should know SQL? That's a great question. We do a lot of training on Microsoft Azure. We do a ton of training on Power BI. And it's interesting to me the number of people that are jumping straight to Microsoft Azure, or they're jumping straight to Power BI and they've never looked at SQL. They don't even know what it is. So if you work with data, if you connect to databases, even if it's from Excel, you should probably know the fundamentals of using SQL to connect to a database and retrieve information, right? That's going to definitely, in a lot of use cases, make your life a lot easier. That's why we're going through this session today, so we have somewhere that we can point our customers just to get a quick little ramp up on how to work with SQL. All right, so everybody essentially who's working with data should be working with that. So kind of circling back real fast to what is a database. A database is a container for data that's structured within our organization for very specific use cases. It could be for one or more applications, and it could be accessible in a number of various ways. Maybe we're accessing it from SQL SSMS or Excel or Power BI, or maybe from some application that's been developed that's going to write data in and pull data out, right? So those are databases. All of us have worked with databases, but I wanted to make sure to kind of just jump in there and cover the fundamentals. Now, like I said, only a couple slides. We're going to jump right in and start writing SQL. The first thing we need to do is connect and authenticate to the Azure SQL database. So I am going to walk you through those steps. I saw a couple of questions coming through and a couple of concerns about that. But the first thing I want to do is, if you have SQL Server Management Studio and you've downloaded it, this is the time when we want to open that up on our machine. And so I'm going to go ahead and open it up on my machine as well. And once you open up SQL Server Management Studio, you're going to get prompted with this connect box that appears right here, this authentication window. I'm pausing for just a little bit so you can follow along. All right, so you're going to see this window right here. And this is where you'll put in that authentication information that was provided in the class files that I gave you. Now, in the server name, you're going to put in the server name. Now, let's say that you canceled this on accident. And you're like, Mitchell, how do I get back to that connection screen? I'm going to cancel mine for just a moment, but don't cancel yours. I'll cancel it. And then right here under the Object Explorer, I can tell that I want to connect. And then I can tell it that I want to connect to my database engine. All right, database engine. There we go. And so now we're going to type in here Pragmatic Works public.database.windows.net. This is going to be connecting to my Azure SQL database that I've opened up so that all of you can follow along if you want. Keep in mind, there's a couple of limitations here. One, a lot of companies, not a lot of companies, but some companies will block port 1433. Port 1433 is required to be open to connect to Azure SQL database. So if you're on a VPN or you're at your company and you're not able to connect, it's possible that your port is blocked by your networking team. And for today, there's nothing we're going to be able to do to help you. So just be aware of that. So if you can't connect, it might be that. So we're going to type in pragmaticworkspublic.database.windows.net, and my coworker Manuel will drop that right there in the chat window for you. And then we're going to type in our login information, right? PW student, and then the password is PW5TUD3NT. Once again, we're going to drop that in the chat window, and that was part of the class files if you went through that PDF document that we provided. All right. So once you put in your server name and you connect with your username and your password, we're not ready to connect yet because we've created something known as a database scoped credential. So you have to connect directly to a database in order to use these credentials. So the next thing that we're going to do is, let me put in mine. We're going to go to options here. And when you click on options, it's going to bring you to connection properties. And we're going to tell it specifically what database we are connecting to. And it's going to be AdventureWorks. All right, AdventureWorks. Hello, Ricardo. I see you there. And so once you type in AdventureWorks, now you're ready to go. You've put in your username, your password, the server. You can click connect and you will be good to go unless either you type something incorrectly or port 1433 is blocked. As you can see, there's a lot of people in here. So if there's an issue, we won't be able to troubleshoot it for you today. All right. So I'm going to leave that up there for just one more moment there. And I'm waiting to see information dropping into the chat window. So there we go. It's coming up right now. So you can start copying that out. We have about a 30-second delay from live to when you're receiving it. I'm going to click connect. And if it works, I'll be able to connect. So let me try that one more time here. I'm going to go back over to my login. PW student might have typed it in wrong. There we go. And then we'll click connect again. Oh, it's not working for me. Did I type in my database? Oh, you know what? Mine's different than yours, so I don't run into problems. My fault. So yours is AdventureWorks. All right. So once you've connected, now we're connected to the server, and we'll be able to see any databases that we have access to, right? And so if I extend the databases over here on the left by clicking that plus icon, I'll be able to see my database. And then I can click the plus button again. That's going to open up a bunch of information. Now, you don't need to know all of that stuff that's there. You don't need to know about stored procedures and views and security. All you need to know is how do I find my tables so that I can extract data from those tables, right? So now I'm going to expand the tables folder, and that's going to show me all the tables we have available. And we have a lot. Now, based on your organization, when you connect to your organizational data, you might not see all the data because maybe they've blocked something from you. But if you're connecting with me today, you should see all the same tables that I'm looking at. Now, what we're going to do is we're going to start walking through the process of actually connecting to our data and writing queries. I want to jump right in and get started today, right? And so for this class, the easiest way to query data is actually to come over to the Object Explorer, go down to the table that you want to query. So I'm going to use person.person, right click on it, and then you can tell it that you want to select the top 1,000 rows. And this will actually write the query for you. This will get us started on our path with writing SQL. Now we're going to write much more than this, but this will get us started, right? So right click on any table. I'm going to use person.person. And then I'm going to go ahead and select the top 1,000 rows. All right, and that'll open that up right here. Now, once it opens it up, it will also execute that SQL query. So down here at the bottom, we're going to be able to see the results. And I can look through here. I can see all of the different columns that are associated with this table. And I can see the first 1,000 rows. And I'll talk a little bit more about top and what that does here in just a moment. All right, so that's that. Now, if you wanted to make a modification to this SQL query, you can. And once you modify it, then you'll come back up to the top right here and you'll click execute. The other option to execute a SQL query in SSMS is you can hit the F5 button on your keyboard. So you can either hit F5 or you can hit execute. Either one of those will work. All right. So here's what we're going to do. We've seen a very basic query. You've been able to test out your permissions and verify that you are going to be able to follow along today. Let me show you the script that we're going to be walking through. So in your labs, and I'm going to pull it over, I won't use it myself, but in your labs, if you downloaded the files, the very first one is called 01 Introduction. I'm going to take that and I'm going to just drag it over and drop it right here in SSMS. You can also just double click on it to open it up as well. But if you just drag it over and drop it right here, it'll open up a new tab across the top that has all of the scripts we're going to use for the very first demo. And as we go from one demo to the next, you can continue to just add them into your SSMS. And so now you'll see that I've added it right here. It's already connected. So if I come down here and select this very first statement and hit execute, it'll give me results down here at the bottom. Now, if you just want to follow along and type along with me, you don't have to use this script, but this will give you the SQL queries that we're working through so that you don't have to worry about making errors as you're following along with me today. Got it? All right. So I'm going to go ahead and not use that because I got notes on the other screen and I'll be going through those. The first thing I want to do here is let's talk about this. This right here is us specifying exactly what data we want to get out of the database, what columns we want to get out and what rows. That's very important. That's what you'll spend the majority of your time doing when you're retrieving information from a database. So I'm going to go ahead and I'm going to get rid of all of that. All right. So what we have now is I have select from, and this is the table I'm pulling data from. Now within the select clause, I have to determine what columns I want to return. The easiest way just to return all the columns is actually to use the asterisk, right? So if I hit Shift 8 and I use the asterisk here and I run this code by hitting F5, it's going to return all of the columns from the person.person table. Also, it's going to return all of the rows of data. So if I go down and look at the very bottom right of SSMS, it's going to show me that we returned 19,972 rows of data. Now what we're going to talk about as we go through this 3-hour session together today is how do we limit the number of rows that are being returned, and how do we also limit the number of columns. And that's exactly what we're going to do right now. So if you don't want to return all the columns, which you probably don't most of the time, also a lot of the times it's considered a best practice, or it's considered a bad practice to return everything if you don't need it, especially if you're working in some of those other business intelligence tools I talked about earlier, like Power BI. Then what I want to do is come up here and let's get rid of the star. So I don't want to return all columns. Instead, I want to return columns from this table. So we see down here the list of columns. I'm going to return first name. You'll notice that when I start typing, the IntelliSense or the autocomplete functionality will pop up to help me out. So I'm going to go down and actually hit Tab to return first name. Then I'm going to put a comma and hit Enter. Because we're going to return more than one column. And when we return more than one column, we separate those columns with a comma, right? So we're going to return the first name. Next, let's also return the last name. So now I'm going to go in here and say, hey, I also want to return the last name. So we're returning 2 columns. I'm going to go ahead and run this again. Your script should look exactly like mine by hitting F5. And now you'll see that I'm returning all of the rows, but I'm only returning 2 columns. So what we've done is we've restricted the amount of data that's being returned from this database to only those 2 columns, but we're still returning all the rows. Later on, when we get to the where clause, we'll talk about how to restrict what rows get returned, right? If I only want to return specific people that have a certain last name, how do I do that? And I do that through a where clause. All right, so that's the first thing I wanted to show you. The next thing I'm going to take a look at is something called aliasing a column. So the way that we store data in a database is a lot of times not the way that we would represent that data and present it to our end users, right? We name things very interestingly. Like for example, this is first name, where we kind of have the uppercase F and the uppercase N. I wouldn't usually put that into a report looking like that. So if you want to alias this and give it a different name, notice how the result says first name. What you can do is you can type in as, and then you can give it a different name. So if I use a single quote here, I could say as first. All right. So I'm giving this a different name and I'm calling it first. If I hit F5 again to run this code, you'll see that right here, the name of that column has been adjusted to the name that I gave it. So you can change the name of these columns when you pull the data out so that it's a little bit more explicit and easier to read and more understandable for your reports. All right, so that's one way of doing it. This is another tricky way to alias columns that I want to show you. I can also do this. I can also type in here something like second or last name. Let's do last name, or we'll just do last. Notice that I'm aliasing this column, but I'm not typing in the keyword as. That does work. That does work. In fact, you could do something like, what would be another way to do this? Let's just call this name. I could do something like name. Now, name is a reserved word, so you got to be careful with that. But if I run this, you'll notice that it does change it to name. Now, this is dangerous. I don't like doing this without using the as keyword, and I'll show you why here in just a moment. All right. So normally if I'm going to give it an alias, I'm going to use the keyword as, so it's very explicit and I can read my code, and then I'll give it the name that I want to give it, and we'll go with last. And we'll hit F5 again, and there we go. So we're returning 2 columns and we're now renaming those columns. All right, so the next thing I want to talk about is how do we order the data? right? So if I wanted to see all of the data that right here is being ordered in alphabetical order by the first name, how would I do that? Well, in SQL, we use the order by clause, right? And so I'm going to hit enter, go over here, and I'll type in order by, and then I'm going to tell it what column I want to order by. Now, you can order by more than one column if you want. I'm going to order by my first name. So we'll do first name, and then I'll run this and I'll hit F5 again. And when I hit F5, that is going to return all of those same rows that we had before, but now it's ordering them based on the first name. All right. Now notice that it's also doing it in ascending order. It's not doing it in descending order, right? So it's doing it in ascending order. If I come back over here and I type in descending order by doing just DESC, and I run this again by hitting F5, it's now going to return those results in descending order. You can also sort this. You'll notice right here that we have Zoe, and then Zoe is a bunch of different first names. They actually look like they might be in order, oddly enough. But I'm going to change this over. So let's do something different here. Let's order by two separate columns. I'm going to start off by using last name. So I'm going to order by last name, let's say ascending, so we'll do default. And then we're going to order by first name also. So we're going to order by both last name and first name here. And I'll go ahead and tell it for first name, let's do ascending as well. So if I hit F5, that's going to order by the last name right here, and then it's going to order by the first name if there's any ties, right? So if you go down to like Adams right here, you can see it's ordering all of these alphabetically, and then for the first name, all of those will be alphabetical as well. So we're ordering the result set, the final result set, by more than one column, and that's very easy to do inside of SSMS. Now the other thing that you can do that's a little tricky, and I'm just going to show you this. I do not recommend this. This is not something I would normally do personally. But the other thing you can do is you can order by kind of the ordinal position of the column in your select statement. So what I mean by that is if I want to order by first name, I could order by 1 and then hit F5. And so I'm ordering by the ordinal position. The only reason I show you that, even though I don't recommend doing that because I recommend being more explicit with your code, is because you might find code online that's doing that and it might be confusing to you. And that's what they're doing. They're just ordering it by that ordinal position. All right. So this is pretty cool, pretty easy stuff, pretty basic. If you've never seen SQL before, maybe not so basic, but for those of you who have worked with SQL, this is pretty simple stuff. Now, what about, here's the other thing I want to do. I'm going to get rid of that order by right there. What if I want to combine for my report the first name and the last name together? How would I do that? Well, the way that I would do that here is I would come up here and delete what's there. And then I'm going to say, hey, I want to do first name, autocomplete. I'm going to go ahead and do a plus, and then let's do a space in between here. So we want to add in a literal string. So we're going to hard code a space in there. And then we'll do a plus again, and we're going to do the last name. All right. Now this is going to, when I run this, it's going to return the full name. But here's a couple of things. One, notice that it did not have a column name. There's no column name associated with this. So we do have to alias that expression. So whenever you're writing an expression in SQL, which you're going to do a lot, you need to make sure to give that expression a name when you're done. So we're going to go back and do that real quick. And the way we do that is we just come to the end, we type as, like we did before, and then we say full name, right? Hit F5 again to execute that code, and now it does have a name right here. Boom, there we go. Easy breezy. All right, so that's how we get just kind of doing some basic concatenation, and we will do concatenation a lot. In fact, another way to do this is a lot of people say, hey, I want to see the last name first. All right, well, I'll just delete this right here, and then now we'll say plus comma space plus first name, right? So if I do that, I'm saying, all right, I want to do the last name first, and we're going to add in a comma and a space, and then we're going to do the first name, and we're going to do that as full name. So we execute that query again, and now we see our final result. So now we're doing last name, first name. So this is, once again, kind of very basic stuff that we're working through here. Now, we're going to move on, and this is the basics of working with SQL. All we're trying to do here is extract basic information from a table. Now we're going to dive in and we're going to start looking at some of the functions and some of the expressions that we can do inside of SQL when we're pulling data from our database. So if you go back and look inside of your class files real quick, we're going to be using this script right here, 02 functions and expressions. And if you remember, all you have to do is just drag that into SSMS, or you can double click on it and it'll add it into SSMS for you. All right. So that's the one that we're going to be working on now, 02 functions and expressions. All right, so let me clean mine up. Now, if you're working through the script, in fact, let me show this because it might be a little confusing here. If you're working through the script, what you'll do is you'll want to manually highlight the code you're running. Because if I hit F5 right now, it will run every single script that's inside of this SQL expression. I should have mentioned that earlier. My apologies on that. But if you're working through the script kind of one SQL query at a time, you want to highlight the code you're running and then hit F5 or then hit execute so that it's not executing everything every time. So my apologies if that's been causing you a headache. I should have mentioned that earlier. That's a failure on my part. All right. So let's go back and look at this real quick. The first thing that we're going to do is I'm actually going to be querying from another table. So when I am writing SQL, and this is just me, different people do this different ways, but when I'm writing SQL, I like to always put in the tables that I'm pulling data from first. So select from, and then I'll type in the name of the table. So I'm going to go with sales.sales order detail. You'll notice that the autocomplete is still going to be my best friend here. So I'm going to hit autocomplete right there by hitting tab. And then I'm going to come up here and specify the columns that I want to return. And so the first column I want to return here is going to be called unit price. All right. Now, if I run this query right here and I hit F5, I'm now returning from the sales order detail table just the unit price. So this has all of my sales information. So as you can imagine, we might do a lot with this in order to get some pretty important information. In fact, if I wanted to see the data beforehand, I might do select star. Remember select star? Select star from it and hit F5 again. And now I can see all the rows and all of the columns. And in here, I can see something like order quantity and unit price. So if I wanted to find out the line item or the sales amount of this line item right here, this row, I would have to multiply the order quantity by the unit price, right? We'd have to do that multiplication there. And that's not being done. It is actually being done for us right here, but I'm going to show you how to do it if it wasn't being done, all right? So that's what we're going to do. So we're going to go back and we're going to do unit price, just like you have in your lab notes. We'll go down to the next line. And then let's just do some basic mathematical expressions here. So I could do unit price plus 10, and then I can give this a name, right? So as plus 10, so we want to give it a name. Make sure to put a comma after each one of these columns. If you don't put a column or comma there, it will cause some problems for you later. And then we're going to do unit price times 2. So what if we just doubled the unit price? And that right there might be, let's do, I'm going to format this just a little bit here. There we go. And that would be as doubled. So we know that we doubled the amount. And then I'm going to do the one we were talking about earlier. I want to return the unit price times the order quantity, right? So unit price, and we'll do times order quantity, and we'll call that one as the line total calculation. There we go. And so what we've done here is some really basic mathematical expressions, some basic functions in order to get that to work. All right. Now somebody said in the notes here, Paul said, hey, IntelliSense isn't working for me. Any tips? The best tip I can give you is always put your table in first and then type in your select clause. Also, under, I think it's under Edit, under IntelliSense, you might have to toggle on completion mode right here. So up here at the top under Edit and then under IntelliSense, there is the option to turn on and turn off completion mode. So it is possible that maybe yours is disabled. So just be aware that that is a thing. All right. So hopefully that helps you out. I'm going to go ahead and run this again, and we're going to see that we get our unit price plus 10, unit price doubled, and then also our line total calculation. And that is going to be right here. It's doubled, and when we multiply it times the order quantity, which maybe we should have returned just for validation purposes, it's giving us that number times 3. All right. So that right there is awesome. Now, the next thing we're going to do, we want to keep building on this. That was just basic mathematical expressions. I'm going to go back to the person.person table here. So let me delete this stuff again. Remember, I like to start with my from clause. So we're going to say person.person. So we get that autocomplete functionality. And we're going to do our first name. Now, a very common function that you'll use a lot when you're working with SQL are string functions, right? And one of the ones I used a lot was the left function. So if I use left right here, what the left function does is the left function returns a specified number of characters from a string. So you pass in the string that you want to return information from, and then you tell it the number of characters you want to return from the left side of a string. So I'm going to type in first name, comma, 3, and then I'm going to do a closing comma. And we're going to say as, and we'll call this first 3, right? So just the first 3 characters here. All right, comma, don't forget to put a comma in there. And then we'll go down to the next line. And now I'm going to say right, and I'm going to do first name again, and I'm going to do 3. What the right function does is it returns a specified number of characters from the right side of a string, from the end of the string, right? So we're going to do 3, and then we'll say as last 3. All right, there we go. We're going to hit execute real quick. We'll hit F5, and you'll see that that's exactly what we're getting here. Now, this is very basic stuff, right? This is going to get much more complex as you dive deeper into the SQL language, but you can do a lot with these basic functions. All right, so that right there gives us our first introduction into string functions. Now, another thing that you can do here, and I'm just going to kind of build on this a little bit, is you could do something like upper. And so if I type upper in here, and I put in first name, I can call this one as upper, and I'll call it maybe upper first, right? So upper first. I also like to format my code so that my aliases are all right there next to each other and easy to find. So you might see me kind of cleaning this up a little bit as we go. And then I'm gonna put a comma here, and we're gonna do another one, and we'll call this one lower. And this is gonna be my first name as well. We'll close that up, and then we'll say as lower first, or first lower, or whatever. All right, and then we'll run that again. And now we see we have the first 3, the last 3, we have all of the characters being uppercased, and we have all of the characters being lowercase. Now, you can start combining these functions together, right? If I wanted to take the first character of this first name and make it uppercase and then combine it with the rest of the character, I could just get the first character using left, and then I could take that one character and make it upper and then join it back in with the other ones using the concatenation we did earlier. Remember earlier we did first name plus last name. So you could take left 1 plus all of the rest of the characters, but on the left 1 you uppercase it, right? Kind of makes sense. It's basic expressions here. So this is how you start tying those together and kind of building this chain of functions within SQL Server. All right, so let me go ahead and replace that, see if there's anything popping up here in the chat window that I can help out with. No, good job. I see a lot of people helping each other out in the chat window. I love it. Everybody gets Mitchell bucks. Mitchell bucks for everybody. All right. So now I'm going to come over here and show you another function. This is called the replace function. This is a great function, right? The replace function will look for a specific character or sequence of characters in a string and replace it with another value. So if I know that inside of my first name, anytime a specific character occurs, I want to get rid of it, then what I'll do is say, all right, look at the first name column, look for the value of A, and replace that with a star. In fact, let's go ahead and return the first name here as well. So I'm going to return the first name just so I can see the results. All right, and I'm going to give this some IntelliSense right here. I need to put a single quote around that. That's my fault. And we'll call this as replace A. All right, so we're going to go ahead and run that code again. And now what you see is anytime A shows up, it gets replaced. Now, some people are going to ask me right now, they're going to say, Mitchell, does this only work for lowercase a or does it work for uppercase A? Is this case sensitive or is it not case sensitive? That question actually depends on how you've set up your correlation on your database. But the replace function is not case sensitive. So I think there's another function called substitute. I can't remember. I might be confusing different languages because I work with a bunch of different ones. But replace is not case sensitive. And you can see that right here. If you come down here to the bottom and you look at Aaron, or whoever that is, you can see the first character of that, which was uppercase, is now a star. So it will work for both lowercase and uppercase. So just be aware of that. Whether that's what you want or not, that's what it's going to do. Now, let me show you another function. We're going to just kind of keep burning through a bunch of these. The next function I'm going to look at here is the length function. What the length function will do is it's going to return the number of characters essentially that correlates to the length of that string, right? And so we're going to say length, and we're going to do length on the first name here. And then we'll say as, and then let's give this a name, something like length of name, all right? And then we'll run that again. All right, we'll hit F5, and now we can look at the length of the name and we can start getting some really good information there. Now, one of the things I want to point out as we're kind of working through this is that I'm showing you a lot of individual string functions, but be aware that when you get into really authoring more advanced DAX for your queries, for your reports, you're going to be tying a lot of these together, right? The length function is a lot of times used inside of other functions like the substring function, which tells it exactly what characters to return from inside a string. So just be aware of that. All right, so we're going to now jump into and start looking at a little bit of date functions. This is, of course, another very common one that you're going to be working with. And so we're going to look at date functions. In fact, I'm going to go ahead and make my text here a little bit bigger so I don't have to keep zooming in and out. So I'm just going to use the mouse wheel on the control button and the mouse wheel to just zoom this in and out. All right, I'm going to come over here and use a function, and I'm actually going to get rid of all of this. And I'm going to say select get date. All right, open, close parenthesis, and then I'll hit execute. And what get date does is get date is actually going to return the current system date and the current system time, as you can see right here. This is exactly what time it is right now, Eastern Standard Time. It is, actually, that's not accurate. That is a little bit, that's UTC time it looks like, so I would have to convert that. But that's exactly what time it is here. All right, so that's going to be the date. Now, I'm going to go ahead and give this a name, and I'll call this as system time. You'll notice that I have no from clause here because I'm not actually retrieving this information from a table. I'm just saying select the current date. All right, what if I get that date down there and I just want to extract the year? How do I get that? How do I get the year from that? Well, there's actually a couple different ways of doing that. And so I'm going to show you two different ways to do that here. One is I'm going to go down to the next line and I'm going to use something known as date part. All right, date part. And within date part, you can tell it what part of the date you want to return, right? So I'm going to say, look, I want to return the year from get date. So from that get date function that we did earlier, I want to return the system year, right? So we're going to say as system time and then as system year. Hit F5 again, and now down here at the bottom, we see that we have not only the system time, but we also have the system year. So we have both. Now, date part is okay, but I'm not really a big fan of date part because there's an easier way to do this. And the easier way to do this is actually using the year function or the month function that exists, which is a simpler version of it, right? So for example, that gives me my system year right there. But if I come in here and put a comma and go down to the next line, I could also say return the year from get date. We close that up. Let's give that a name right there. We call that system year 2. Going to give us the exact same results, right? So I hit F5, go down to the bottom right here, and we'll see both of these expressions essentially return the same thing. So one of the things about SQL that you're going to find out as you start authoring SQL and working with it and getting more familiar with it is that as your knowledge grows, you're going to find out 4, 5, 6 different ways to do the same thing. Now, a good developer is eventually going to figure out the most effective way to write queries so that they return in a performant manner. And so you're going to learn how to performance tune your queries. So it's good to learn different methods and different ways of doing things, right? All right, so that is the year. Now let's also go ahead and return the month. We could use date part for this, or we could use the month function. What I'm going to do is go ahead and just type in month, open that up. We'll do get date open close parenthesis, and then one more closing parenthesis on the end. And then I'm going to type in as system month. So we're giving all of these columns and all of these expressions a name. Remember what I said before, actually, if I were to get rid of this, it will still work, but it actually won't have a name on that column, right? It has no column name. So you do have to remember to kind of alias those columns and give them the appropriate name. The other thing that I want to show you, and I've been holding off to kind of show you this, is that you got to be careful when you are selecting. So let's do this. I'm going to go down to the bottom real quick to show you the problem. Let me move this down a little bit. So I'm going to say from, all right, and I'm going to say person dot person. All right, so from person dot person. And I'm going to say, you know what? I actually want to return the first name also for whatever reason. So I'm going to go ahead and say, all right, let's return the first name. Now, the chat window is a little bit delayed here, but I'm going to ask the question anyway. What is going to happen when I run this query right now? When I run this query, what's going to happen? Is it going to return the first name? And pay very close attention to what I'm doing. I'm going to go ahead and run it. We'll see what you guys say. And you'll see that I'm getting something very interesting here. For the first name, I'm getting the value of 4. Well, it's April. So the month is actually returning 4, but the name of my column is first name. Like what's going on? What's going on here is I did not separate this expression from this column with a comma. I didn't do it. And because I didn't add a comma, the SQL engine thinks that I'm trying to alias the month as a new column name of first name. So that's why I tell you I prefer to use the as keyword here to be very explicit in my code so that I know that I'm giving it an alias. If I put a comma in here now and I hit F5 again, now it does what I would expect. It gives me my system time, year, year 2, gives me my month, and then it gives me my first name. So that's just one of those gotchas that gets a lot of new people. Yeah, there you go, Kumar, great job. Edison got it too, good job. Forgot the comma, right? So very important to do that. I'm gonna come over here and say as, and we'll do system month right there. And now I'll add a comma on the end and run it again. And now we get the system time, the year, the month 2, and the first name. All right. So that is kind of just a quick introduction into date functions. Now, let's keep working down this path here, right? We're going to keep working down this path. So the next thing that I want to do, and I'm looking at my notes over here on the right, so I stay in kind of lockstep with what you're doing as well, is we're going to look at the date add function here. All right, we're going to look at the date add function. So, and we're going to be using the sales order header table. So let me delete all of this code. I'm going to point to another table, right? Sales order header right there. And then from the sales order table, or from the sales order header table, we're going to go in there and say, let's return the order date. All right, I'm going to show you a couple things we can do here with the order date. So we're going to do order date. All right. And then we're going to go in there and we're going to do date add. And date add will allow us to add or subtract time from a date. Now, a lot of times right now, I'm actually looking at my order date in my sales order header table and I want to subtract time from it. And I'll talk about a use case for this here in just a moment. And so I'm going to say, hey, I want to add a year, but I'm actually going to do -1. So I'm going to subtract a year, and I'm going to subtract a year from the value of order date that we saw above, right? And so we'll give this an alias here. We'll call this one something like as from, let's see what's going on here in just a moment. Should be good. All right, as previous year. So I'll call this something like previous year right there. And we'll pull that. All right, so that cleaned it up right there. And we run the code again, and we hit F5. All right, and when you hit F5 and we come down here to the bottom, you'll notice that we took the order date and we extracted 1 year from the order date. Now, I see there's a lot of great questions about SQL that are coming through in the chat window. What I'll do is after we take our first break, I'm going to come back and I'll go through a couple of those and I'll actually show you how to do some of the questions that you guys have. So make sure that you come back after the first break and we'll take some of those Q&A questions because it'll be a little bit more efficient to do it at that time. All right. So this right here is going to give me my sales order header. Now, there's some other things we can do with this, right? For example, for example, what if I wanted to say that this is the date that somebody ordered something and the due date, right? Let me see if I have this in my notes. I don't. Good. So this is going to be a little bit extra. This is not in your notes, but the due date is going to be in 3 days, right? So anytime somebody orders something, they need to receive that order within 3 days. How can I, within my query, generate the due date? Well, I would say, all right, let's take the order date and we're going to add 3 days. So we're going to add here the day. We're going to go in here and then add in 3. So we're going to add in 3 days to the order date, and we'll call this one our due date. All right, that's going to be the due date. That's when it's due. That's when it should have been delivered. So if I run this query again and I hit F5 and we come down here, we will see that from the day of when it was ordered, we've added 3 days to it, and that's now the due date, right? So that's a more practical example of something that you will probably be doing when you're extracting information from the database. In fact, when we're teaching Power BI, and I bet a bunch of people that are in here today are Power BI users, when we're teaching Power BI, we always tell people it's a best practice to actually write a query against your database and extract exactly the data you want, and you can perform expressions during that operation so that you don't have to clean the data and transform the data inside of Power BI desktop, right? And this is exactly what we're talking about, is if you want to set up a due date that's 3 days from the order date, you just do what we just did, all right? Very easy. Now, let's take a look at another function here. I'm going to leave that there, and we're going to use the dateDiff function. All right, so we're going to say dateDiff, and inside of our table, we have 2 columns. We have a column for order date, and we have a column for ship date, right? And so if it was ordered on the 5th, but it was shipped on the 10th, then that means it took 5 or 6 days for that order to be shipped. And so I want to return the number of days it took to ship. So we can look through all the transactions, figure out which ones took too long, and then we can go and look at our process and try to fix that, right? So I'm going to say I want to get the difference in the number of days, so we'll start with days, between our order date and our ship date. All right, and let's give this a name. I'm going to call this our days to ship. All right, days to ship. So we're getting the difference between the order date and the ship date, right? Just tell me how many days, what is the difference here? And we're going to hit F5 again. And I can see that it looks like the majority of them are 7 days. Now, there might be some that are less than 7 days, and I don't want to sort through 32,000 rows. So what I can do is, let's build on what we did earlier. I'm going to order this by days to ship. So I'm going to hit enter, go back. I'm going to say order by. And then I'm going to type in here days to ship. All right. In ascending order, because we want to start from the lowest number first, and ascending is the default functionality of the order by. So we'll hit F5, and we got some that are null. That's kind of odd, actually. Let's see. Is everything null? I would have to really dive in. So it might be that we have some that haven't shipped. Let's look at that. So I'm going to bring in the ship date here. Whoops, we're going to talk about null values later. Let me type in ship date, and then we're going to run this query again. And there you go. We have some that have a null ship date. There's no value for it in the system, and so therefore it's returning null. I'm going to talk about how to deal with nulls later in this session, because nulls are very, very important when you're working with databases. All right. So that shows us a little bit more though, right? How we can continue working with these date functions, these date expressions, to return that information and return that data from our system. All right, I have one more example in this lab that we're going to take a look at, and that's figuring out how many months it's been since the order took place. So I want to compare the order date to the current date today. Well, we already know how to get the current date today. We use the getDate function, right? So all I need to do is say, what is the difference between the order date and get date at the month level? So we're going to use dateDiff. So I'm just going to add once again to the expression that I have because it's easy. So I'll do a comma. We'll do dateDiff here. And then we're going to do a difference at the month level. So we'll do month. And we're going to say, what is the difference between the order date and get date, which is today? Right? Open and close parenthesis there. and I'll just call it months difference. Month since order is what I have in our notes. All right, and I'll go ahead and hit F5 to run that again. And now this is going to tell me how long it's been since those orders took place. And if we scroll down, we'll be able to see some other examples that show up, like 105, and keep going through, and we'll see some different things here, right? But this is how you can start building on that data. So we don't just pull data out of the database. When we pull it out, we can clean it, we can transform it, we can modify it, we can use SQL or SQL to do that. And that's exactly what we use all of these expressions and functions for. In fact, a lot of times you might be pulling this data from a staging system where the data is raw, it's never been cleaned, it's never been transformed, and you need to load that into a very specific table in maybe your reporting database. And so you have to clean it up as part of that moving process, right? So SQL is actually very, very important here for those types of, we call it ETL. Extract the data, transform it, and then load it in its new destination, right? SQL is a very big part of ETL operations. All right, so we're going to jump into the next section here, and it's going to continue to get a little bit more complex as we continue to move along. But the next section is going to be looking at, let's see what it is actually. I think it's going to be null functions. Yes. So now we're going to start talking about null and what null is, because it can be a little bit frustrating to work with in databases. So grab that, drag it over, drop it right inside of SSLMS, or you can double click on it, and if you have SSLMS open already, it'll just add it to your existing SSLMS. And we're going to now work with these null functions and kind of talk about that a little bit. Brian says, cleaning data, will it cause a load on the server? That's a great question, Brian. The answer is yes, of course it will, right? So what happens is you got to be careful. This is where we talk about performance. Actually, if you're extracting data and you write some very complex queries, it can actually not only put a load on the server, you could actually lock up tables, you could lock up the temp table, you could cause a lot of problems based on writing inefficient queries. Now the queries that we're writing today would not cause those kind of problems. These are very straightforward. Select these columns and do this. But when you get into working with temporary tables and variables and common table expressions, and you get into really a lot more advanced SQL, that's when you have to be very aware of what you're doing and look at execution plans and stuff like that. Now, I'm going to tell you about this later, but at Pragmatic Works, we have an introduction and an advanced DAX class. We have a DAX bootcamp, and we dive into those very advanced topics there. That's why we do these events, right? We want to sign you up as customers, make no doubt about it. But yeah, it can absolutely cause a load on the server. That's an awesome question. All right. So let's take a look here, and I'm going to flip over in my notes to the null in the top distinct. So now we're going to take a look at the null function. Now, what is a null value? A null value in a database is not a blank, it's not an empty. What it means is unknown. Null values represent an unknown value. For example, a lot of times when people fill out information inside of a form, they'll put their first name and they'll put their last name. But a lot of times we don't put our middle name, right? So we don't put it. So when you put it into the database, you don't put that they have no middle name. You just put null. You're like, I don't know what their middle name is. So it's null. It's unknown. So null kind of represents an unknown value. So here's a question for you. What is 1 plus null? If null is unknown, then the result set is unknown. What is 5 plus null? Unknown. It's null. What is first name plus middle name, which is null, plus last name? The result is going to be null, right? And so Sanat said, I should have said advanced SQL and introduction to SQL class. So I apologize if I said DAX. I should have said introduction and advanced SQL class. Those are completely different topics. I probably misspoke, so my apologies. Thank you for letting me know that. So when we're working with nulls, you got to account for the fact that they're unknown. And you're going to see some interesting problems here as we work through this next example. So let me clean this up just a little bit here, and then I will get rid of the order by, and then I'll get rid of the from clause. All right? All right, so here we go. Select from, and we're going to start with person.person, right back to our same table we've been working with so far. And in the select clause, I'm going to tell it that I want to return the first name, right? And then we'll do a plus, and then we're going to do a double or a single quote, space, single quote, plus. And I'm going to add in here the middle name, and then we'll do plus, single quote, plus, and then we'll do the last name. Now remember, we also want to give this a name, so I'll call this full name. And then for the sake of just being able to read the code a little bit better, I'm going to add the first name, middle name, and last name as separate columns in our final result set so we can validate the code here, right? All right, so here we go. We're going to do first name, middle name, and I'm typing it a little bit fast, but you already have the completed example, so just keep that in mind. And then I'm going to go ahead and run that code again. And we're going to see some interesting results, but it goes back to the fact that a null value is unknown, right? So let me zoom in here. You'll see that for the very first row, we have Syed E. Abbas, and that one looks correct. It looks awesome. But when we get a little bit further down, for example, right here to Kim Abercrombie, we're getting a null value for the full name. And the reason for that is because the first name is Kim, the middle name is unknown, and the last name is Abercrombie, right? So what's happening is it's saying, look, we don't know what the middle name is, so we can't get you the final result set because first name plus unknown equals unknown. All right, so that's where we need to be kind of careful here when we're writing code that works with null. So how do we solve this, Mitchell? What do I do to solve this problem? Well, there's a few different methods for working with null values. As I mentioned before, everybody's going to have their own way of writing code that makes sense to them. But let me show you an example. If I know that middle name is a nullable column, meaning that it could have null values. Because when we set up, here, let me give you a little bit of a breakdown here. When you set up a table, or your engineers or your database administrators, whoever is responsible for creating a table, let me kind of break it down. Whenever you create a table, you're going to do some stuff on the back end of that table. You're going to specify what the data type is of that column. You're also going to specify whether a column can be null or not. So you'll notice person type is not allowed to be null. If you try to load an unknown value into the person type of this table, it will fail, right? Good job. I see PA Beater said use coalesce. Yes, we're going to do that. Good observation there. You'll notice that suffix can be null, but last name cannot. So if you know by looking at what we just did right here that a table can be null, you probably want to account for that in your code, right? Because you don't want to accidentally report on data that's null and then you get unknowns. So if I know that middle name can be null, which it can, what I'm going to do is come in here and say, all right, if it's null, so we'll say if it's null, we'll use is null here, and I'll show coalesce in a minute because I actually prefer it better. If middle name is null, just go ahead and return a blank. Don't return anything. Now, let me be very clear. This is not a complete example because when I run this, it will fix the first problem, but now we have two spaces that we're adding in, which is kind of a little bit wonky. So I'd have to build some conditional logic around this one right here to say, look, if middle name was null, also return a blank space here. Don't return a space, just don't return anything, right? So let me go ahead and run this again real quick. We'll hit F5. So that's one way you can use is null. But I like the recommendation there, right? We could use coalesce. So let me show you what coalesce does and how we can use it. So you'll notice right here that for Kim Abercrombie, that value is no longer returning unknown because we just said, look, if it is unknown, just return it with a blank. So our expression now says first name plus blank plus last name, right? So it's no longer unknown. Good job. Now, I like coalesce a little bit better. Coalesce has a lot of cool functionality. What coalesce does is coalesce says return the first non-null value in a list, right? So if I were to do something like coalesce and I said, all right, first, if middle name is not blank, return middle name. All right, so we'll say middle name, just like this. But then we'll say, if middle name is blank, then return the next column, which is going to be a string. Now you could have multiple columns or multiple values in here and it'll grab the first one, right? So for example, I'll just go with this. This is fine. So if I hit F5 again, you'll look and you'll see the results are exactly the same as what I did a moment ago and exactly the same as what is inside of your notes, inside of the lab notes that I provided for you, right? So that's one way of working with nulls. We're going to keep doing this. We're going to have a couple other examples as we progress through the 3 hours. I think there's a couple more examples when we get into where clauses on how to deal with nulls because they can cause quite a bit of frustration and confusion if you do not account for them. All right, so what's the next thing we want to take a look at? At the very beginning today, we ran a query that was select top 100 star or select top 1000 star from person.person. And I told you that that returns the top 1000 rows from the table. It doesn't return all the rows in the result set, it just returns the top 1000. So I want to take a look at that again and really kind of hone in on what that does and what we can do with the top function. So I'm going to delete everything in my select clause. All right. And then once we get rid of the select clause here, I'm going to come in here and say, all right, from, and the from we're going to use is going to be sales order detail for this one. So we'll do sales.sales order detail. And then up here in my select clause, I'm going to just do star, right? So I'll just do star, select star. Remember what star does, it returns all the columns from the table, and I'm going to hit F5. And when I hit F5, if we go down to the very bottom right, you will be able to see, I'm probably blocking the screen there, but you'll be able to see that we have 122,000 rows of data that's being returned. All right, so if I escape and we come back, what we want to do is reduce the number of rows that are being returned, right? And so what I can do here is I could say top 10 star. So I'm saying, all right, return all the columns, but only return the top 10 rows, which is just going to be the first 10 rows that it comes across. So I'll hit F5 again to run that code, and you can very, very clearly see in the result set that I only have 10 rows of data that's being returned, right? And so this is pretty nifty, pretty handy. There are times where you might want to return your top 5 salespeople, return your top 10 regions, your top 10 departments. And so you set up your entire expression, you order it, and then you return the top 10 from that expression. I'll show you that here in just a moment. But this is a quick way also to sample your data. If you have a billion rows in a table, I don't want to do select star from my billion row table. I'd rather say select top 10 from that table and just kind of sample the data real quick, and then I can write my expression. Another way that you can do this is you can do something called top 10%. So if the table has 121,000 rows of data in it, right? If the table has 121,000 rows of data, you could do top 10%, and top 10% would return 12,000 rows, right? And I was trying to look at the chat window there and got, somebody said repeat something again, but unfortunately there's a delay, so I just don't know what it was. And I'll hit F5. All right, so this is going to return, once again, only 10% of the rows of data. Another kind of a cool way to work with your data by just doing something like top 10%. All right. So this is top 10. We're going to kind of build on this a little bit more. Let's go ahead and instead of doing star, we're going to actually select the columns that we want. So I'm going to tell it that I want to return the sales order ID from my table, and I'll do a comma, go down to the next line. In fact, the way I like to do this is I'll put top up here. All right, and then we're also going to return the sales order detail ID. All right, so we're only going to return 10 rows from the table, but we're telling it exactly what columns we want to return: sales order ID and sales order detail ID. Now I'm going to come down to the bottom right here. I'll click execute, and when I click execute, we're getting exactly what we wanted to return, which is just going to be those top 10 rows. All right, now that's going to be top 10. Another function, and I'll do one more function and then we'll kind of we'll take a lunch break here or 15-minute break in just a moment. But the next thing I want to talk about a little bit is distinct, right? So if you were querying data and pulling data from, let's say, your product table, and somebody comes to you, so here's the request, right? Somebody comes to you and says, hey, can you give me a list of all the products, or really just all the different colors of products that we have? So this is your job. I want you to go to the SQL database, go to the production.product table, and return a list of all the colors that we have for different products. So you say, hey, this is going to be easy. I'm going to do select, and I'm going to say color from production.product, and then I'm going to hit F5. And when I hit F5, I get a list. But the list is a little bit confusing here, right? Like, it's a lot of rows. Black is showing up multiple times, null is showing up multiple times. So how do we fix that, right? How do we get rid of those duplicates when we're returning that information? Well, I can use the distinct function, right? The distinct function will do exactly that. So I'll come over here and type in distinct, and that's going to get rid of any duplicates that's in my data. So then we'll come over here and click F5 again, and now we're getting a much more comprehensive list. That's exactly what we were looking for, right? Now, we're not done. This is scratching the surface. When we come back, we're going to dive into joins and aggregations and the really cool stuff that people get interested in, right? But before we do that, as I mentioned before, one of the things that we're here and what we do at Pragmatic Works is we do training. We do live training, we do virtual mentoring, hackathons, and of course on-demand learning. And so as part of this event, we are going to have a sale where you can buy our on-demand learning at 50% off for $247. Now, if you're watching this on the recording later, unfortunately, that sale is probably not going to still be available if it's more than 5 days from today. But for those of you who are here, we have a sale where you can kind of pick that up. Now, on our on-demand learning platform, we have 2 classes here that you can take a look at. One is going to be our Introduction to SQL class. The other is going to be our Advanced SQL class. And as you can see right here at the bottom, the Introduction to T-SQL class is almost 9 hours in length, and the Advanced T-SQL class is almost 14 hours in length. And those are recorded. That is a lot of content. We also, if you go to our website, we also have a DAX bootcamp that's coming up. I don't have the exact date with me right now, but we have a DAX bootcamp that's going to be coming up here in maybe a month. And you could join me in that DAX bootcamp, and we'll have a lot more time to really get into the intricacies of SQL. I might have said DAX again. I do so much DAX, I apologize. But we'll have a lot of time there to really dive into SQL and talk about those different topics. So that's my spiel. Not going to go any further there, but if you're interested in training, that's what we do. That's how we stay in business. So just reach out and let us know, and feel free to sign up for that subscription online. All right. So I'm going to put a timer on the screen, 15 minutes. Go get yourself something to drink. And when we return, we're going to continue working through SQL. All right. Thank you, everybody. We'll see you back here in just a little bit. All right, welcome back everybody. We are going to jump right back in where we left off. But first, I want to take a look at some of the questions that we had. Not a lot of questions. Manuel's been hitting them as soon as they come into the chat window. But I want to take a look at a couple of the quick questions. So one of them was, how can I return the 3-digit month? Now, a lot of you who probably have worked with DAX or taken our DAX training are probably like, oh, I know how to do that, because it's actually the exact same function. So if you want to return the 3-digit month, you can use the format function in DAX, and that will return the 3-digit month. And so that was from Kumar. This expression right here is essentially how you would do that, and I'll put that in the chat window here in just a moment. Also, we got another question. How can I return the first day of the month, the first day of the year? Well, really, that's going to be a combination of functions. Now, how you do it is going to be up to you, because there's a couple different ways you can do it. But what I did here is I'm first going to return, and just let me go ahead and run this entire script real quick. What I want to do here is I want to return, first of all, the last date, the end of the month of the get date expression that we're returning, right? So get the end of the month. So if we're looking at April, get April 30th, and that's exactly what you're going to see right here. Then I take April 30th and I add -1 month to go back to the prior month. All right, so that's pretty easy. All right, and then from there, you'd have to get the end of that month and then go forward one day. So you just keep building out these expressions to ultimately get there. Once again, I just put this together real quick on break, but there's a couple different ways you can get the answer to this. This is just one way that you can do it, by kind of leveraging date add, end of month functions to make that happen. All right, so that right there is that. Now, there was another question. There was 2 more questions. One, Nebula was asking us about removing duplicates, right? So if you have a lot of duplicates in your data and you're trying to return the query and you're having a hard time finding those duplicates, that's actually a little bit tricky. My method, and the method that I prefer, is out of the scope of this 3-hour session, but I prefer to put all of that kind of into like a temporary table or like a common table expression, where I actually give anything that's a duplicate a row number, right? So if it's the same, it'll have row number 1, row number 2, row number 3. Then in a subsequent query, I'll say, all right, select everything from that temporary table or from that common table expression that has a row number equal to 1. So then I only return the distinct values. Once again, depends on how complex your scenario is, because you could get away with just using distinct if it was just a couple of very simple columns, right? But a lot of times on more complex examples, you might have to do something that requires a little bit more work, like common table expressions, temporary tables, things like that. Now, the other question we got, and this was a ton, I saw it just getting bombarded in the chat window there, is null versus coalesce. All right, so let's revisit this real quick before we jump back into our demo. Is null and coalesce are a lot of ways they are alike, right? The big difference here is that if I do first name plus middle name, but I want to make sure I don't return the null value if it's a null value, I can use is null to simply say, look, if middle name is null, return this value, whatever I specify. I could say return, hi, my name is Mitchell. I could return whatever I want there, right? But I could replace that value with something else. Is null only accepts 2 parameters. So if the first one is null, return this expression. Coalesce is a lot more flexible and versatile than is null. So for example, you'll see in my coalesce expression right here, I said first name plus, what coalesce does is you can pass in multiple values, and it will return the first non-null value from a list. So middle name, if it's null, it'll check the next item in the list. Well, null is obviously null, so it'll skip that, and then it'll return this item. Hi, I'm not null, right? So I actually can't put I don't want to get into qualifying that. Hi, not null. All right, so something like that. So coalesce gives you a little bit more flexibility and versatility. But if you just want to check a single value, see if it's null and just replace it with something else, just use is null. It's super easy. But coalesce gives you more functionality, right? So if I run this right here and I execute that code, you'll see that coalesce right here that I didn't give a name, if there's a null, it's returning Kim, hi, not null, because that's the expression that I gave it the option to return. A little bit confusing, but it's the same. In a lot of ways, coalesce and is null are the ones you'll use to replace a null value with something else. Which one you use is going to be up to you. Nebula says, can you use distinct on multiple fields? The answer is yes. In fact, Distinct, unfortunately, will always work on multiple fields. So when you are bringing back multiple columns, but you only want to bring back the distinct first name, it doesn't work that way. It will do a distinct across all the columns in your query. That's why when you have multiple columns that define uniqueness, but not all columns, you might have to do something a little bit more complex. So great question. All right. Is there something like not null? Yeah, there's a function called is not. Where is not null? Yeah, and we'll get to that later, Tom. That's a great question as well. All right, so here we go. We're going to get back on track here. Lots of great questions. What I'll try to do after this event, and I try to do this after a lot of my events, is I'll either do a blog or I'll do a follow-up kind of 15-minute YouTube video where we go through and answer a lot of those questions, because these questions are gold. They're great. I love them. And so we'll definitely circle back. All right. So we're going to go back and look at distinct, right? We were working with distinct right before we went on break. And what we're going to look at now is, we got distinct, yeah. So let's do this. If I go back and say select star from production.product here, and I hit F5, and we go down to the very bottom right, you'll notice that there are 504 rows of data in our table, right? 504 rows of data in our table. Now what if, and we just had a question from somebody just a moment ago, what if I go in here and I were to say distinct star? What distinct star does is it's saying, look at all of the columns. So literally look at every single column here. And if you find any row where all the columns are exactly the same, if you find any row where all the columns are exactly the same, only return the unique ones. But it is going to look at every single column by default. That's just the way it works. So if I run this and I hit F5, and we go back down to the bottom again, you'll notice that we still have 504 rows. So distinct made absolutely positively no difference here. Distinct essentially said, look, every single row of data for the columns that you gave me, every single row of data is unique. So it's going to return all of those rows of data. So that is a gotcha when it comes to distinct. And that's where you might have to start using things like common table expressions, temporary tables, row number functions, window functions, and things like that. Really cool stuff. I love writing SQL, but distinct does have that limitation. All right, so we did color, we did that. Let's start taking a look at the where clause. So if you think about where we're at so far, right? So far, what we've been doing is we've been just bringing back every single row from all of our tables. We haven't really been reducing our result set. And as a best practice, if you're connecting to a fact table and that fact table has millions of rows or hundreds of millions of rows of data, we need to reduce that amount of data. Only bring back the data you want. So if I want the last month of data, I'm only going to bring back the last month. But how do I do that? We do that in SQL through the where clause. All right, so let's do this. I'm going to switch my query back over to sales order header. All right, and I see people like Ricardo and Lucas and other people answering questions in the chat window, so thank you guys for doing that. We will get into aggregate functions here very soon, so we will finish that up before the end of the day today. We still have an hour and a half together, so we have a lot of time left to cover a lot more topics. All right, so we're going to be pulling data from sales order header. Just trying to make sure I'm in my notes correctly so it matches what you guys have. Almost there. There we go. So we're going to be pulling data from sales order header table, and I'm going to bring back a couple of different columns. I'm going to say, all right, let's bring back customer ID. I'll move my mouse out of the way. And we're also going to bring back our sales order ID. And then let's also bring back the order date. Now, if I hit F5 right now and I execute this query, it is going to return all of the data that's in that table, at least all of the rows. We've limited it down to 3 columns, but it will reduce all of we've limited it to columns, but we haven't reduced the number of rows yet. So how do we do that? We do that with the where clause. So I'm going to go down to the next row. We'll say where, and this is where we can start doing some filtering. So I'm going to say where customer ID equals, and we're going to go with 29825, which is one of the customer IDs where someone has made purchases. So pretend, for just a moment that this is your customer ID at some restaurant that you go to, at some grocery store that you go to. And so every time you make a purchase at that location, your customer ID is recorded in the transaction table, right? So we're trying to figure out for this customer, what is a list of all of their transactions? So now I can hit F5, and when I hit F5, it's going to return for me all of the transactions for that specific customer. So let me zoom in right there, and you'll notice the customer ID is exactly the same on every single one. I can see every order for that customer. So now I can do things like the minimum order date to get the first order date for that customer, the maximum, the total number of orders for that customer. And that's where we start getting into aggregates, right? That's where we can really start getting some pretty cool stuff with SQL. But right now, we're just limiting the result set that gets returned. And so we're saying, hey, filter this down to where customer ID equals 29825. Now, you can do some other kind of odd stuff here. If I were to say where 1 equals 0, just think about that for a moment. What do you think is going to get returned from this table? Well, the answer is nothing, right? Because 1 never equals 0. Now, this seems like a really odd scenario here, but there are times when I've written SQL in the past where I have used that expression. Specifically when I create a table from a table and I just don't want to load any data from it, I'll do where 1 is 0. So this is a thing that you can do when you are doing this kind of where clause, all right? All right, so let's take a look at something else that's a little bit more complicated with the where clause, still using the sales order header table. I want to tell it that I want to return all of the sales from my sales order header table for the year 2013, right? So imagine that we're looking at this data and we have data for all years, but we only want to return the data for that year specifically, year 2013. So now I can come in here and say where order date, right, equals 2013. The problem with that is that order date is not a year, it's an entire date. So that is not actually going to work the way that I want it to work. And so we're going to combine some of the things we've learned so far. Where the year, so extract the year from the order date, equals 2013. So I'll do this and I'll say year. So we extract the year equals 2013. Now I can hit F5 and this is only going to return, we can look at the order date here, it's only going to return the data from that table that is equal to 2013. Now, it is very important that I explain to you that this can be a bad query that can cause performance problems, because when you're working in tables in a database, a lot of times we will index columns. So if you want to know, we're not going to get into this too much because it's complicated, but think about a phone book, right? And some of you, maybe you're so young you've never seen a phone book, but in a phone book, if you go to the very back, you have an index. And in that index, if I want to find out Mitchell Pearson's phone number, I'll go to the P section, I'll find Pearson, and it'll tell me exactly what page Mitchell Pearson's information is on, right? That's awesome. It's fast. Well, SQL Server has something very similar where we can put indexes on columns so that it keeps that information. If I had an index on order dates where my query could go look up the pages where those order dates are so it doesn't have to read all the data and it will perform better, I just invalidated that by what I did. So you got to be careful how you write your where clause, because even though you can do this, it might not be a best practice. In fact, a better way to write this might be where order date is greater than or equal to 2013 January 1st and order date is less than 2014. That would hit the index, that would perform better. Now, once again, we got 3 hours together. That's more complex. That requires more knowledge of databases and the internals of databases, but it behooves me to at least give you a little bit of that information. All right. So this does work. We can look through. We can see that we have 14,182 rows. If I were to hide my face, come down here to the bottom. So that is significantly less rows than what's in that table. I think the table has 122,000. So that filter did work. Let's look at another filter. Do you remember earlier how we were working with the left function? So we were working with a string function. Well, we can do that here as well. I could say, all right, return from the sales order header table. Let me make sure we're, oh yeah, it is a different table. That's what I was thinking. All right, so let's switch this over to a different table here. Person dot person. Oh, okay. So we got a question from Tom here. How do you know when to use is or equals? So Tom, I really only ever use is when I'm working with null values. So where, because a null value doesn't equal. So order date equals null is not a thing. It's where order date is null. So where I use is when you're working with nulls. And we're actually going to get to an example of that here in just a minute. So great question. We'll get there in just a moment. Outside of that, I always use equals or less than or greater than a normal operator. All right, so we're going to do from person.person. And let me go ahead and delete all of this right here. And let's see what information we want to return. So we'll return, of course, our first name. We'll return our last name. And then down here in the where clause, we're going to say where first name starts with or last name starts with S. So if we want to return all of our customers where their last name begins with the letter S, we'll say left. Remember how we did left earlier? Left, last name, 1, we only return one character, equals the character of S, right? And so once again, if you have an index on the last name, this is not efficient. This is not a good way to write this query. There's other ways we can try to write this query to get better performance. And so I'm going to go ahead and run this query real quick, hit F5, and if we go through and we look at the result, every single row that gets returned is only going to be characters or only going to be customers that start with the letter S. So we're writing the where clause now to filter down the results that are being returned. Very important. Many different ways we can do this. All right. So let's do this. I am going to, actually, I apologize. I meant to send everybody this information earlier in the chat window, and I did not. So I'm going to copy that real quick. There you go. And then the other one that I wanted to share with everybody here, and I'll put that, in fact, let me get Kumar, I apologize. Let me get your name out of there. There we go. All right, and I'll share that for everybody as well. All right. So the next thing we're going to do is go back over to our sales order header table. Let me make sure that's correct. Yes, it is. And we're going to return some information again. So we'll get rid of the where clause. I'm going to change my select statements. Once again, if you're following along in the files I gave you, you're not having to delete and type everything. Just move down to the next block of code. And I'm going to change this to customer ID. So let's say that from the sales order header table, I want to return all of the customer IDs where the customer ID is equal to 11,000, right? So if I run that code right there, I should only see the record for the customer ID where it's 11,000. So I can see that this customer had 3 transactions in our database. Now, what if I want to see all of the customers that are not? Somebody asked about this earlier. I want to see all the customers that are not 11,000, right? I want to see all the customers that are not 11,000. What I can do is come over here and say where it's not equal to 11,000 like that, and hit F5 again. And now we're not getting 11,000, but we're getting everybody else, right? All of the other customers are showing up. Another way to write not equal, and I saw somebody put this in the chat window earlier, is you can come over here and hit exclamation point equal. That also is going to be the equivalent of a not equal sign. So where customer ID is not equal to 11,000. We hit F5 again, same exact result as before. It's just another way to write that query. Now, we got a question just a moment ago from who wrote this question. I see one there. How do you know if the info is indexed? From the Rachel Dooley. A little bit tricky, Rachel, because it's a little bit beyond what we're going to be talking about in this class. But if you come over to your table, you can come in and look at the actual indexes that have been put on that table, and then you can script those out and you can look at those indexes. So depending on what level of permission you've been given, you can come in here and see that on my table I have an index on business entity ID. All right, so that's how you get into it. You do have to sometimes script them out because the name might not be indicative of what the index is. So you'll script out the code by right-clicking and scripting it to a new window. All right, do functions not allow for alias use? Do I need to use the original name? No, so not whenever you use a function like first, you can alias it when you get done. Yeah. All right. So we did not equals to and equals to. Also, you can do greater than, right? So if you want to use operators here, like greater than 11,000, you can do greater than. So I can say where customer ID is greater than 11,000. Or let's do something else. Let's say where customer ID is greater than 11,005. And I'm going to go ahead and order this by, so we can see it, order by customer ID. So we're going to order by customer ID in ascending order. And when I run that, you'll see right here that we are not getting any customer IDs that are less than 11,006 because it has to be greater than, right? So you can use operators. And I brought this up earlier when we were doing a filter on the date. And I said more effectively, a more efficient way to retrieve data from that table would be to say, look, where the date is greater than or equal to January 1st of 2013 and the order date is less than 2014. That's a more efficient way to use the index if it exists than to say where year of order date equals 2013, because the year of the order date is not an index column, so therefore the engine would have to read all the data and it could take longer. All right. Now, once again, that's a little bit more complex, but I do want you to know that there are efficient ways to query your data to improve performance. And sometimes it's the little things that matter. All right. So that's going to be ordering by customer ID using that. We could also do something like less than, right? Of course, we could do where customer ID is less than 11,005, and we can run that. What if we wanted to do an and condition? So where customer ID is greater than 11,005 and customer ID is less than, let's say, 11,040. I don't know. And we'll hit F5. So now we're saying the criteria is it has to be greater than and it has to be less than. So if we look at this here and we go all the way down to the bottom, it stops at 11,039. So you do have the ability to do a little bit more complex criteria, right? Now the next one I'm going to look at is very similar to what we just did. You'll notice that this does not include 11,005. So if you want to include 11,005, you would add an equal sign here and you'd add an equal sign here. So where it's greater than or equal to 11,005 and where the customer ID is less than or equal to 11,040. Another way to do this exact same expression is actually to use something known as the between operator, right? So I could come in here and do something like this. Excuse me. Where customer ID, and I'm going to say is between, right? So instead of doing greater than, we'll say is between 11,005 and we'll give it another number here. So we'll go back and it's between, I don't know, 11,015, a little bit less this time. All right. And I'll hit F5 again. And then we'll see that we are getting, it does include the value. So we're getting 11,005 all the way through 11,015. All right. Let's see here. Yep. All right. So just looking at the comments, it's not an interruption at all. The questions are great. I try to make sure I answer them at specific times so we can keep the class flowing. But this is how you do a between operation here. Now, you can also do alpha characters, right? So if I wanted to do something like, let's see, we're going to transition back over to person.person table. And we'll do person.person. And then I'm going to do first name, last name. And then let's say we want to do where the last name. So watch this. This is pretty cool. I wouldn't recommend it, but it's pretty cool. We'll say where the last name is between, right, A and C. All right. So select all of the rows from the person table where the last name is between A and C. Now you might think that it's going to return all of the last names that start with A and all the last names that start with C. However, if I run this, you'll notice right here at the bottom, in fact, let me go to the very bottom here, that it actually will end at the letter B. If I had a last name that was exactly C, C and only C, it would work. But since I don't, anything that's CA or CB or C whatever, that is greater than just the character C, so it doesn't get included. Now, I don't know when you would actually ever do this, but it is something that you should be aware of. It does respect that. Now, let's look at something that's cool, really cool. We're going to look at something known as the like function. What the like function allows you to do is the like function allows you to come in here and filter it on some kind of wildcard criteria. So for example, if I want to return all of the last names that start with the character S, earlier I showed you we could use the left function. Left last name character 1 equals S, right? You can also use the like function. So if I did like, and then I did character S, and then I did wildcard, what I'm saying here is return all of the first name and last name rows from the person.person table where the last name is like S with any number of characters afterwards, right? So as long as it starts with S. So if I run this query right here, you'll notice down here in my result set that the only thing that gets returned are names that have the character of S, the last name, right? Unfortunately, there's a lot of rows, so we have to kind of filter through it and look through it, but that's what that does. Now, you can also do something like this. What if I just want to return any last name that has S anywhere in the name? Doesn't start with it, doesn't end with it, but anywhere. At the beginning, the middle, the end, anywhere. What I can do is actually put a wildcard on the beginning and say, hey, just return anything that has an S anywhere in that code, hit F5 again, and you'll notice right out of the gate, we're getting ones like Abbas here where the S is at the end. And if we go down further, eventually we'll find some where the S is in the middle, like with Alonzo or Allison, right? And so that's another way to use the like expression. And so even though sometimes the like function is not necessarily the most effective from a performance and an indexing, it can be really, really helpful when you're trying to find very specific data or you're troubleshooting or debugging or whatever it is, right? All right. Another way to use like, a little bit less common, would be maybe to do something like this. So I'm going to say Anderson, and then instead of typing anything there, I'm going to put an underscore, and then we'll do an N, and we'll close that up. And so what I'm saying is where it is ander S, any character here, it doesn't matter, and then S. So let's go ahead and hit F5 to run this, and we're getting a bunch of records. In fact, I am going to comment out the first name, and I'm just going to return a distinct list of last names here. So I'm only going to return the last names that are being returned, a distinct list, a unique list, and I'm going to hit F5, and you'll see that I'm returning Anderson with an E and Anderson with an O. Interesting, right? So we know that people spell their names a lot of times very, very differently from other people, and it's just the way it was spelled. And so if you're trying to look for everybody who has a name that's very similar, you can use something just like this. I want to take a moment also to thank Manuel, who is working like a madman in the chat window to answer all these questions. He's doing an awesome job. Thank you, Manuel, for all your help there. I know it's a lot of questions coming in. All right, so that's how you can do that right there. The other way you can do this is you could be more specific by using an open and a square bracket and then specifying what those characters can be. So if you don't want it to be anything, you could specify very specifically what those characters could be by saying E or O. And then if I run it again, it's essentially going to give me pretty much the same result that I got before. And you come down here and it's the same result. It's just a different way to get the same thing. But this is more explicit, right? We're adding some specificity to what we're doing. All right. Let me look it down a little bit further in my notes. I think we're almost done with this section here. We actually got quite a bit left. All right. So here's another one that's really cool that us SQL developers really love to use, right? So instead of using the like clause here, we can use something known as the in clause. Now in, you provide a list and say return all of the rows from this table where it's in this list. So return all of the records from this table where the last name is in the list that I provide. So for example, if I come in here and say in, and I do Smith, and then I also do Anderson, like this right here, and I close that up, and let me add first name back in real quick, so we'll get a combination of unique first name and last name combos. This will only return the rows where the last name is in this list, either Smith or Anderson. And you can make this list as long as you want. The in clause is very, very common when you're working inside of SQL. So I'll hit F5, and then we're going to get a very long list of all of the people with the last name Anderson, and then all of the users who have the last name Smith. If there's any duplicates, we got rid of those because we did use distinct, but that is going to give us that right there. So that's the in clause. Another thing we can do here is we could come in here and say where the, let me see, I'm going to skip that one. we'll say where the, let's try this. So where, I do want to do one more in clause, but I think this is good enough. So we're going to look at the person.person table, and we're going to say where the first name, all right, equals Haley, and the last name equals Barnes. So this means that both of these criteria must be true. We're using an and condition here, and we're saying, look, the first name must be Haley, the last name must be Barnes. So I'm going to go ahead and run that again by hitting F5, and I'll get rid of distinct now. And we get one record that matches that criteria. That's exactly what we were looking for, right? We knew there were a bunch of Barnes, we knew there were a bunch of Haleys. We wanted to pull back that exact customer, and that's how we can do it, by putting in two different criteria where they both have to equal true. Now you could also do an or condition, and that means where the first name is Haley or the last name is Barnes. So maybe we have an idea of what the name is, but we're not exactly sure how to spell it. So just bring back all the records that are similar to that or whatever. And then you'll see everybody who has the first name Haley or has the last name Barnes is going to be returned, right? And so that's pretty straightforward, I think. You just got to get used to writing these where clauses, but we're going to say or. All right. Also, there, like I said before, if you wanted, you could try to do something like first name equals Haley or first name equals Haley without the I. So without the I could do either one. And if I run this again, now we're going to get a combination where some of them have the I and some of them do not. So we're saying one or the other. Now, in this example here, we could have used a like condition. We could have used the in clause. You already, in the very little time that we've been working together, can probably see that we could have written this where clause in a couple of different ways. Edison says, does capitalization matter? So generally, no. Most databases are set up with a correlation that's not case sensitive, right? So it all comes down to case sensitivity of your database. My database is not case sensitive. Most of them are not. So capitalization does not matter. In fact, just to prove it, if I were to make this a lowercase h and I did the same thing over here and I run it with F5, we're going to get the same results back again. So good question. And I just don't see all the questions, guys. So I grab the ones I see that pop into my purview there. All right. So that's pretty cool. Let's see what else we got. Now, order of operations. Check this out. Order of operations matters. So now we're going to say, all right, where the first name is Haley or the first name is Haley or actually and. So we only want to return records where the first name is Haley and the last name is Barnes. We don't care what the first name is. Kind of odd results. For example, I'm getting a lot of people without the last name Barnes, and that's not what I wanted. I'm like, for me, in this example, I want to make sure that we only return records where the last name is Barnes and the first name is either Haley or Haley without an I. That's not what I got. So order of operations matter. You want to make sure if you're doing some more complex logic like this, that you use things like open parentheses, right? So I'll do an open parenthesis here to say, look, this or this has to be true and this has to be true. Now, if I do that, we're going to get much better results here. And you'll see we only get those two results. All right. So definitely we want to include parentheses there to get the best results. So nothing that you don't know from a basic mathematical class. Same kind of concepts will matter here, like what we've been looking at before. All right. The not predicate. So there is something else. I don't like this predicate, but I'm going to show it to you because to me it can be more confusing than not. Let's say that we were doing where last name equals Smith, right? So where last name equals Smith. One way to say where last name does not equal Smith is you can actually go to the beginning and say not last name equals Smith and hit F5. I'm not a big fan of that, right? I would much rather just say where last name is not equal to Smith by doing like we did before. So you got those brackets right there. But there are, once again, multiple different ways you can write SQL, which includes adding that not keyword at the beginning. Remember earlier we did in, so we said where last name, let's say, is in, and then when we say in, we'll give it a list. We'll say is in Smith, and it's in Barnes. Now in this situation here, not can be really, really helpful. So where the last name is in Smith and it's in Barnes. Now, what I could do is come in here and say where it's not in Smith and it's not in Barnes. And now if I run that again, we're going to get all of the records where the last name is not Smith and it's not Barnes. So that is very, very helpful. But in most cases, I try to avoid negative logic because it's confusing to me. And from my experience of working with other people, it can get to be a little bit hard to kind of nail down when you're working through more complex code. So I try to avoid it when it makes sense and when I can do something a little bit easier to read. All right, so we did not in, we did like earlier. You can also with the like statement, so remember how we said where last name is like, and then we did something like S% and we ran it. That works and it gets us all the last names that are like S. We already know that. We already did this earlier. You can also say where last name is not like S, meaning return all the rows where the last name does not start with S, right? And so then I can execute this query again, and we're going to get all of the records from that table where the last name does not start with S. And so we're just kind of building on this concept of using that not keyword in order to return kind of the opposite of what you might expect here. So not in, not like, not equal to. You can use that in many, many different places. Now, we're going to transition a little bit. That was working with the where clause, and we're going to keep working with the where clause, but now we're going to take a look at working with null values, right? So for example, I might have the first name, the middle name, see if I can get this working for me correctly, and the last name, right? And if I run this query right here and I hit F5, this is going to return every single row from my person.person table, 19,972 records, right? All right. However, you'll notice here that we have a lot of records that have a null value. So what if, and this goes back, I think Tom asked earlier, somebody asked earlier, how do you return the rows that don't have null values? So I could come in here and say where, right? Where middle name is null. Now this is where you use is or is not instead of equal, because null is an unknown. Null never equals anything. So you'd have to say where middle name is null. You can't say where middle name equals null. So we'll say where middle name is null. This will only return the rows from this table where the middle name is null. And we'll see down here at the bottom, that's 8,499 rows. You can also do something like say where the middle name is not null by typing in this right here, and that will return all of the rows where the middle name is not null. So I'll go ahead and hit F5 again, and you'll see that we're now returning all the rows where the middle name is not null. All right, pretty cool stuff there, but you do have to be aware of the fact that a lot of databases, almost all databases somewhere, have null values in them, and you have to account for that when you're writing your SQL queries, especially if you're doing something like where middle name is equal to B, right? So watch this. If I say where middle name equals B, and we're going to write down the number of rows here, and my head is going to be blocking the bottom right-hand corner. But if I run this, down in the bottom right-hand corner, it says that this returned 291 rows, right? 291 rows. If I change this and I say where it's not equal to B, and I run it again, it's going to tell me down here in the bottom right that it is 11,182 rows. Now stick with me, this is really important. So when the middle name is B, it equals 11,291. When it's not equal to B, so when B is not equal, it's going to be 11,182. Well, here's the thing. Our data set has 19,000 rows of data. So where are the other 8,000 rows of data? The other 8,000 rows of data do not get picked up when you do an equal and a not equal, because null is not one of those. Null is unknown. So you almost have this like three predicate logic. You have the equal, the not equal, and then you have the is null. So if you want to get the full 19,000 rows and you're writing your logic like this, you have to include not null somewhere. Now you could say where middle name is not B and, watch that, and remember that, and middle name is null. And now if I run that, that is not going to give me, actually, sorry about that, I messed up, or middle name is null. And if I go down to the bottom now, we're now going to see that we have 19,681, not the 11,000 we had a minute ago. So now we're taking in account the null values. Very important to not underestimate this. I've been on some big consulting projects where we had hundreds of lines, thousands of lines of code, and whoever was writing the code forgot to take into account the nulls, and we would spend hours trying to validate and figure out where the problem was, and just to find out that that's why the numbers weren't adding up. So be careful, because that can definitely make a big difference. All right, let's see here. All right, this is good. This gets us right where we want to be. We're moving on to the next section. That's going to be module 4. So I'm going to go back over to, once again, our class labs. And in the class labs, we're going to now open up joins. Joins, union, and cast. All right. So this is something you're going to be doing. Normally when we do our, we do a free, we don't do it as much now because of how often, we haven't been traveling and stuff, but we used to have a lot of people come to our office, and we did something called the Foundations class. And it was a full week of SQL that we did for free for people who kind of were in the military, changing jobs, and stuff like that. And so they could get an opportunity to start with this technology. And where people would really get caught up was day 3 when we got to joins, because joins can be a little bit confusing, right? So drag it in. Once you drag it in, you'll have that SQL query right there that you can use. Obviously, I'm going to keep working with this query right here, and we'll just keep working through that. In fact, let me open up my notes over here. All right. So let's talk a little bit about what a join does, right? If I am looking at, let me kind of modify this real quick. So I'm going to come over here and get information from my sales order header table. All right. And then up here in the top, I'm going to get some information from that table. So we'll call this our customer ID from my sales table. And then I'm also going to return my c.account number. Well, we don't have that yet. We'll get that in a minute. Let's also just go ahead and return our sales order ID. All right. Now, if I run this, this is going to give me some really good information. In fact, let's grab the order date as well. All right. So we're going to go ahead and hit F5. And this returns my customer ID, my sales order ID, and my order date, which is great. But you are building this query for somebody else on your team, right? You follow me? And the other person on your team says, wait a minute, I want to see the customer name. And you're like, well, the name isn't in this table, right? Like, just to be clear, if I come up here and I return all columns from this table, the customer name is not in it. The customer name is stored in a different table, right? So how do I get the customer name and the customer information from that table into this result set so I can see both? That's where joins come in. We join the tables together. If you're familiar with Excel, it's a VLOOKUP. If you're familiar with DAX and Power BI, it's the equivalent of doing a merge, right? Or if you're inside of DAX, it's the equivalent of doing like related or a lookup. So what we're going to look at here is how do I do a join? Now there's a couple things I want to talk about. Let's do the join first. So first, and by the way, there's different types of joins. There's inner join, left outer join, right outer join, full outer join. Then there's some kind of non-equi joins. I'm not going to get into that level of complexity today. So we're going to focus with just inner joins. We do have some other YouTube videos that I've done a long time ago where I think I do an advanced SQL video from a few years ago that kind of probably talks about this more, but I just don't have time today to dive into that. So do be aware there are different types of joins, and it does make a big difference. But I'm going to do what's known as an inner join, and I'm going to type right here and say inner join, and I'm going to join the sales order header table to my sales.customer table. So sales.customer. All right. Now you also have to tell it what column they're related to. So think about this for a minute. You're looking at a page. So you pull out a page of information. You're looking at that page and you go down the list and you're like, oh, I see this order right here and it has a customer ID. And then you know over here you have another customer table. So you're going to go look at that customer table and you're going to look for that customer ID. Once you find the customer ID, then you can find their name and everything else. So the condition that we join these tables on is the customer ID. The customer ID lives in both tables. So I have to tell it I want to do an on condition on customer.customer ID to sales order header.customer ID. Now, I can't just say customer ID because that's going to cause confusion for the query because customer ID lives in this table and customer ID lives in this table. So one thing I could do is I could type out, sales order header dot customer ID, and that will kind of work, but it's a lot of work. I don't want to type all that out. So what I'm going to do instead is, remember how we aliased column names earlier? You can do that with tables. So instead of typing out sales order header, I'm going to give this a name, and I'm going to say, all right, sales order header, let's give it a new name of SOH, sales order header, just to make this query easier. I'm going to do the same thing for customer as well. We'll say as, right? And we'll just say cus. All right. And so now I can come down here and say, all right, let's do the join on SOH dot customer ID equals cus dot customer ID. And then up here at the top, this is a problem because I'm telling it to return customer ID, but the query says what customer ID? The one from the sales order header table or the one from the customer table, right? And the one that we want is actually going to be the one from the customer table. So we'll do that. Now I also, from the customer table, I also want to return here the account number, I guess. Maybe I don't have the name in there, but we can grab like the account number. Maybe that gives me more information. So we're going to return, the entire purpose of doing this join was to now get information about our customer in the final result set along with their sales order ID. Now when we get to aggregate queries here in just a little bit, you're going to see where this really adds a ton of value because we can get the name in addition to the total number of purchases, the total number of transactions, their last order date, all of that we can return in our aggregate query. But if I run this query now, we just did a join between those two tables. And so now I have the sales order ID and the order date from my sales order header table. And I've brought in, and I'll put that in red, the customer ID and the account number. I've brought that in from the customer table. And we did the join on customer ID. So I know the information, as long as my data is valid and not bad, I know the information is correct. And so now I'm getting more information about that, right? And so that is an inner join. Now, by the way, if you don't specify inner join right here, it will do an inner join by default. So you don't have to specify inner join, although I would recommend it just to be more explicit with your code. But if I run this right here, it's going to give me the exact same results. But keep in mind, there are different types of joins. There's left outer joins, right outer joins, inner joins. So you do want to be a little bit more explicit with your code when you're writing this out. All right. So the next thing I want to look at here is, and I'm going to slide down a little bit. We're going to jump into, I'm trying to look. We're going to jump into union. So joins are quite complex. We definitely spend a lot of time in our DAX classes online and our boot camp talking about joins, the different kinds, how to find bad records, how to find duplicates, all kind of stuff like that. But what I'm going to do now is talk about something else. We're going to talk about the union function. Now the union function allows you to bring two tables together. So pretend that you have a historical sales table or a historical products table and you have your new products, right? And you want to add all of your products together in a single table. Well, how do you do that? You can use the union function. Now there's two different functions we're going to talk about here. One is called union, and the other, if you will, is union all. So if I did select one, and I ran that query right there, select one is going to return select one, just a literal value of one. Now if I want to combine that result set with another result set, what I can do here is I could say union, and then my other result set would be select two. And when I run this, I'm joining them together into one single result set, right? So I have two rows of data now instead of one. Now, the interesting thing about this is, watch this. I'm going to do, let's make this union all for just a minute. Let's add another one. I'm going to do union all again. And I'm going to say select one. So when I run this, you should expect that we're going to have three records at the end. We have 1, 2, and then we have 1, right? So we have three records. Now, if I change these from union all to just union, you're going to notice something very interesting when I run it. We now only have two records. So by default, you got to be very careful with which one you use here. By default, when you use the union function, it will return, it will get rid of all duplicates. right? So since 1 was a duplicate, and this is sometimes a really good thing when you're joining two tables together that might have a lot of duplicate data because you have, different systems that are storing it. Union can be really great to get rid of those duplicates automatically. Union all will keep all records regardless of whether there's duplicates or not. So you do got to be aware of that. Now let's look at this in a more practical example here. And this one, let's see, this one's a little bit longer, so I'm going to copy it over so we don't have to type it all out, and I'll just talk about it. But this is where you can combine information from 3 different tables. So let me zoom in real quick, and this is the exact code that you have in your notes, in your lab documents. So what I'm doing is selecting the business entity ID. I'm combining the first name and the last name as the full name, and then I'm saying this is employee. I'm going to do a join over to my person table on business entity ID equals business entity ID. Now, once again, you're new to SQL today. This is going to be a little bit complex for you to look at, so don't worry about it. I'm going to take all of that result set right there. So if I run that, I can run it independently. It's going to give me this right here. I'm going to take that result set and I'm going to do a union all, and I'm going to combine that to this table right here that has all of my vendors, purchasing.vendor. And then I'm going to join that to this table right here that has all my customers. So I'm taking all of the people that are in my database, the employees that are in the employee table, the vendors in the vendor table, the customer in the customer table. I'm taking all of that and I'm going to put it into a single table that has my employees, my vendors, and my customers, right? So if I come back out and I run this code right here and I hit F5 and we go through it, you'll notice that we have employees right there at the top. Let me see if I can find a quick little cutoff here so you can see it. Yeah, it's taking way too long. There we go. Employee, vendor right there. So you got that cutoff, and then customer right there. So we have all the records from our customer table, all the records from our vendor, and our employee table or whatever it was. So we have all of those users in a single table, right? And so union is a set-based operation. It's one of many that we'll use inside of SQL, but it's an easy way just to combine tables together. Once again, if you're from Power BI Desktop, in Power BI Desktop, this is the append operation when you're appending data together to kind of mash that data up, all right? So that's the union and the union all. You can also do a union between data sets that in some ways don't even make sense, so be careful with that. The other criteria to a union that you should be aware of is when you union multiple tables together, they need to have the same number of columns. So if I were to go to my first result set right here that has 3 columns, business entity ID, and then it has my full name right here, and then it has employee. If I were to add a column to that, and let's just say I added the hard-coded value of 1 as random new column, so I add a new column here. If I run this code again, it's actually not going to work because it's telling me that all queries that are using functions like union, intersect, or except operator must have the same number of expressions or same number of columns. So that is a very big thing to be aware of. Whereas in like Power BI, if you're using this functionality with the append operation in the query editor, that's not a requirement. So that's a little bit different there. Also, you want to put them in the same order. So whatever the first column is here, it's going to be mapped to the first column here. So make sure the order of those expressions are the same in each of those different result sets as well. All right, so a question here from Jennifer. Jennifer says, when would you use a union versus a join? So they're significantly different, right? A union is where you take 2 result sets, and I have 100 rows here, and I have 100 rows here, and I want to have 200 rows that has all the rows of data, like this example. So that's a union. A join is significantly different because what a join does is allows me not to add more rows, but add new columns. So maybe I have a customer table that has the customer name, the customer email, the customer phone number, and I want to add to that result set the total sales for that customer, the total number of transactions for that customer, the last order date. That would be new columns that we're adding to that result set. We're not adding new rows, right? So a join is when you want to get information from a related table and you want to add it there as a new column. A union is when you want to combine those 2 tables together. All right, so hopefully that made a little bit of sense. It does take a while just to get familiar and comfortable with those. All right, so I'm looking over at the notes real quick. Union, union all, we took a look at that. That looks good. Okay, so one more thing I do want to take a look at here that is pretty important is cast operation. So doing a cast. So watch this. If I were to say, I'm going to delete all of this, and I'm going to make this very simple. If I said select one, and then I said union all, and I said select A, we now have a expression that has two different data types. This is an integer, and this is a text value. And so what it's telling me down here is I'm getting a failure message. So for those of you who maybe haven't written SQL before and you've worked with like Power BI, the DAX language is very forgiving because DAX doesn't require you to always convert your data types. SQL is not. A lot of programming languages like .NET and SQL are not very forgiving. You have to specify what the data types are and you have to convert them. And so right here, it's saying, look, you can't combine these two together because it's trying to convert the letter A to a data or a numerical value, and that doesn't work. So what I'm going to do is come up here and change the value of 1 to a string value. So I'll come in here and say cast, right? Cast the value of 1 as varchar, all right? And so you can do something like this where you say just cast it as varchar. I actually don't need that there. And I'll say as ID. So I'll give it a name so that we have a name at the end. And now if I run this query again, now it works. I can have both the value of 1 and the value of A in the same column because they're both string values, okay? So you will have to do things when you're writing SQL and you're trying to combine columns together. If you're trying to combine 1 plus A, that might cause a data type problem. So you'd have to convert the integer column, the product ID, the business entity ID, whatever it is, convert it to a varchar, a string, that's what a varchar is, and then you can combine it with the numerical value, all right? Yes, Michael says, can you just, Mitchell, you're making this too difficult. Can you just put quotes around the 1? Yes, you can, right? So I could technically just say 1 and that'll work. That wouldn't work for a column if you were pulling a column from a table like business entity ID, but in a situation like this when we're hard coding the values, Michael, yes, you could just put quotes around it. Good question. All right. So will the access to the database remain after this class? The answer to that, David Davis, is yes. The database will be there after the class is over. We use this one for a lot of different training events we do on Azure, Power BI, SQL, so it will be there and it will be available. So feel free to come back and go through those demos again. Now, we're going to move into the last section here, probably the favorite section, the best section, where we get into actually writing aggregate queries. So that's going to be the next query in your result set. It's going to be number 5, right? So we're moving on to module 5, where we're going to be writing aggregate queries. So go ahead and open that up, double click on it, drag it into SSMS, and you will be able to follow along also with this next section. Now, this is pretty cool. I like aggregate queries, and you will be doing a lot with aggregate queries. Also, I should tell you, my favorite functions in all of SQL are window functions. Now, we're not going to get into window functions today. They are a little bit more advanced, but I love window functions, and you can do some really cool things with them. So let me do this. I'm going to go over here, and we're going to write a new one. We're going to do okay, so when we're talking about aggregates, we're talking about doing things like count, min, max, sum, just basic aggregate queries, right? So for example, if I say select, oh, what just happened there? Messed up. Control Z. All right. Select from the table. And the table we're going to use is going to be a table that has a lot of aggregate data in it. So we're going to go with sales order header. And what if I want to just find out what is the number of total transactions in that table? I just want to count the number of total transactions. Well, what I can do is I can say count star. So just count, everything in the table from sales order header. And when I run that, it's going to show me right here that that table has 32,332 rows. In fact, I can give this a name and I can say something like as total rows or total transactions in that table. Now you can also be more explicit and you could do something like count, and you can add a very specific column like salesperson ID. And that should, unless you have null values, once again, this is where we talk about blanks or nulls, unless you have null values, this should give you the exact same result as total rows. So I could call this one as count of salespeople. All right, now we're not doing a distinct count, we're just doing a regular count. So the numbers that we get should be pretty similar here, but they're not. And so this is where you got to start looking at your data, finding out if I have blanks, if I have nulls, what's going on with that, right? And so this is another way you can count a specific column. Now, what I want to show you is a couple of different functions that we can do. And so we got the total rows here. I'm also going to do a sum, and we're going to do a sum on our total due column. So there's a column in there called total due. That's how much somebody owes us from that transaction. And we're going to say as total sales, right? So that's our total sales. We're also going to do a min on that exact same column here. So that's going to be min of total due. And that's going to be as the minimum cell. So what was the smallest cell that we had across all of those records, right? So that would be our smallest cell or our minimum cell. Then we could do maximum here. So just showing you a bunch of quick aggregate queries to get you familiar with them of total due. And we're going to say that's our maximum cell. And then for the final one, we're actually going to do average of total due. And that'll be as average cell. Whew. All right. So if I run that query real quick, and I come down here to the bottom, this is going to show me the total number of transactions, the total amount of sales, the minimum sell, $1.50, the maximum, the biggest order that we had, $187,000, and our average sell. In fact, if we were to take the average sell and do it across our total rows, it might come pretty close to what our total sales were, right? So this gives us a lot of aggregate information. Now, there's a little bit of a problem with aggregate queries that really throw people off. Okay, so this is just basic stuff here. You have that exact example in your SQL query that I provided. Let me clean this up though real quick. I'm going to get rid of everything here, and then we're going to do another query. And what I want to do in this one is I want to say, all right, let's do customer ID, and then I'm going to come down here and say, let's sum up. So instead of just getting the total sales for all customers or all products, I want to get the total sales for my, I want to get the total sales per customer, the sum of sales per customer. So we're going to say sum, and I think the column is called total due, right? And we'll say as total sales. But if I run this, I'm actually going to get an error message, and this throws a lot of people off. If you run a query where you're doing a select statement and you have any items in your select statement that are not aggregated and you have items that are aggregated, you must put that item in a group by clause, right? So for example, if I comment this out, let me get rid of this real quick. If I comment out this code and I run it, it runs fine, no problems, right? I get my customer, every record for that customer, and it works. But as soon as you introduce aggregations, minimum, maximum, sum, average, as soon as you introduce those, you now have to start thinking about the group by clause. And so for example, the sum is an aggregation. It's good to go, but the customer is not. We're not doing minimum customer. We're not doing maximum customer. We're just doing customer. So what you have to do is go down here and type in group by, and then you want to group by the customer ID. Now I'm even going to take it a step further, and let's say order by, and we're going to order by total sales descending. So we're going to order by this new column that we created. Now it might be complaining about it because it's saying, hey, we can't order by the column that you just created here. So you might have to actually type out sum of total due, which I would not expect it to do that unless it's complaining about the group by needing to come later. Let me see here. But I thought order by was last. Yeah, that's odd. Let me mess with that here in just a second. But let's do the group by first, and then I'll come back and show you how we can do that. So we'll do this, hit F5, and then what you're going to get over here is every customer ID is going to show up one time and only one time only because we're grouping by the customer ID. So whereas customer 11,000 might be, in fact, let's do the order by on customer 11 on customer. So order by, right, customer ID. If I hit F5 here and you come back down, you'll notice that customer ID, even though 11,000 really shows up in this table many, many times, we're only getting one record because we're grouping by that customer and we're getting their total sales. Also, if I want to know the total transactions for that customer, I could do that. I could do count star, right, as total transactions, right? How many times did they show up in the order header table. How many times have they ordered? So I think 11,000, that customer should be 3 if I remember. And so if we run it again and you come down here, that customer has 3 total transactions. They've frequented our business 3 times. And so you can continue to build on this, but just be aware if you come in here and you add any columns to this select statement that are not an aggregation, you're going to have to add them to your group by clause, right? And that's going to be pretty important to be aware of. All right, so let's do another example here. Order by to works, yep. All right, so let's do this. I'm going to come over here and instead of doing customer ID, let's say we want to look at our sales by year, right? So instead of doing it by customer, we want to look at our sales by year. So we're going to use a function we learned earlier in this workshop. We're going to use the year function, right? So we'll do year, and then we'll come in here and say we want to pull the year from the order date, just making sure I got the columns correct. All right, and we'll say as order year. Put a comma in there. There we go. Now this is going to be, this is not an aggregation. This is not an aggregation. So if I run this query real quick, let me get rid of all of this. If I run this, I'm going to get an error message again. And it's telling me that the order date, which is appearing in my select clause, is not aggregated. So this is not going to work. So this expression right here has to be put into a group by clause if you want this to work, right? So this is where a lot of people who are new to SQL really get frustrated and aggravated, is doing joins and doing aggregations. All right, and so what we're going to do is go down to the next line, and we're going to say group by, and we're going to group by the year of the order date. All right, we're going to be very specific. And then we'll hit F5, and now when we come down here, I can see my sales by year and the total number of transactions that occurred each year, right? So we're doing these aggregate queries and getting some really good information here inside of that. All right. So this is good. Let me look back over at the notes. We did that right there, did that, that's perfect. Ooh, this is a good one. All right, so let's circle back to the where clause. This is pretty good. So let's say that this query is fine. I don't have any problem with this query. Let's say that you only want to return rows where the sum of total due is greater than 10,000, right? In fact, let's switch it back to customer ID. So I'm going to switch it back to customer ID. I'll put a comma in there. We're going to group by customer ID down here. All right. And then we're going to go ahead and order by customer ID again so you can see the results. So let's do order by customer ID. All right. So we're going to do it again. All right. F5 to run that. This looks great. But you're going to see that some customers have $9,000 in sales, some have $125 in sales. And then if we go down further, we'll see some that have $10,000 in sales, $12,000 in sales. So we have people that are all over the place. So here's the request. Your manager comes to you and your manager says, I want you to return a list of all of the customers that have $9,000 in sales or greater. And you're like, oh, no problem. I already have the query. I just need to filter it down to where the sum of total due is greater than 9,000. Like, that's super easy, right? So there's a couple ways you can try to do this. First of all, I'm going to say where. One thing you got to get used to at SQL also is the order of where you put things, like the where clause, the having clause, the group by, the order by. There's different ones here. But I'm going to say where, and let's just do total due. So I'm going to say where total due is greater than 9,000. Right? And if I hit F5, that will work. That will work. But it's only going to work for single transactions. Well, actually, no, if there is total due, it'll work. But what I actually want to do here is I don't want to do total due. I want to do the sum of total due, right? Because total due is individual transactions that occurred. So we're going to say sum of total due. Now, this is going to cause a problem. I'm trying to look and see if anybody is already telling us the answer, and they're not. But I'm going to do where the sum of total due is greater than 9,000. Now, when I run this, we're going to kind of get some unexpected results, right? So we'll do F5. Wait a minute, we're getting a failure. It says an aggregate may not appear in the where clause unless it is a subquery We're not getting into subqueries today, but that kind of falls into that category of temp tables and CTEs and derived tables. In a having clause. Oh, a having clause. Okay. So what it's telling me is we actually need to do this in a having clause, not inside of the where clause. All right. So if you're doing some form of aggregation and you want to filter down by the aggregation, you actually have to put that in something known as a having clause. This is going to take you just a while of writing code to get used to. But if I want to filter by this result set directly from my select clause, I need to do the having. Now, if you were to put this into a temporary table or a common table expression or a subquery, which is what it's saying, and then you select from that subquery, then you could say where total sales is greater than 9,000. But since I'm doing the where clause immediately after the select, that's not going to work. And so I'm going to go ahead and get rid of all of that right there. And then I'm going to go after the group by clause, and we're going to say, all right, having, so this is where you'll type out having a sum of total due greater than, we could do equal to if we want, 9,000. All right. So where we have a sum, and I'm going to put this on the next line, greater than or equal to 9,000. If we run that, we are now only going to get a list of customers where the total sales is greater than 9,000, period. You will not see, and that's across all their transactions, not just a single transaction, right? So if I have a $3,000 transaction, I have a $5,000 transaction, I have a $2,000 transaction, that's going to be very, very important here. Now, one of the things that you're noticing as we go through this is that where you put your select statement, your from statement, your group by is going to matter. So if I try to do the having clause before the group by, doesn't really make a whole lot of sense, right? First, you have to group it to do having clause because it's getting grouped. So you'll see I get an error message here and it says incorrect syntax near group. And the reason it's incorrect is because the having clause needs to come after the group by. Now the where clause would have come before because first you filter it down. So let's spend a couple of minutes here getting a little bit more advanced, all right? If you come in here and get rid of this right here, the basic syntax, if you are doing a SQL query, you always want to have a where clause in there. And the where clause is going to filter down the result set really most times before you do other things. So for example, if I am writing a basic query, and in that query, first I'm going to tell it from, and you tell it the table that you want to pull data from, right? And then the next thing you will do is essentially you're going to filter it down and say, all right, remove these rows from table. Make sense? And so that's kind of our order of operations where we're going to be starting here. So first, select the data from this table, then remove these rows. You don't actually get to the select statement until after the rows have been filtered, right? And that makes sense because I don't want to do a sum or a max or a min or an average over 1 billion rows and then filter them out afterwards. So this is very effective from the SQL execution plan that gets generated. It's going to look at the from, it's going to filter it down, then it essentially starts working on the select statement after that, okay? And then it'll go through those other operations where it does the group by, it does the having clause, it does the order by. And so in the order of operations, if you're looking at this, the order by is going to essentially be the very last thing that gets executed within that. So everything gets done, everything gets performed, so then you can run your order by clause at the very end, right? And so this is the fundamental order of operations. There might be a little bit in here that I didn't cover just really quickly off the cuff, but it is important to understand the order, and that order affects performance, but it also affects how you have to write your SQL query when you start getting into things like group by clause, order by clause, where, what comes before what in that statement. All right. So Robin says, this is great stuff. I love it. Perfect. Best comment of the day. Yeah, everybody who works with data, you need to write SQL, right? You need to understand the fundamentals because SQL isn't super difficult. All I'm trying to do is retrieve data from the database. Now, there's a lot more you can do with SQL. Creating tables, writing, stored procedures, creating views, inserting data, updating data. But for what we're talking about here today, just extracting data and retrieving data from a database, you're just writing where clauses. You're just writing select statements and pulling information out. Now let me look over at the notes again. We just did the having clause. You can also have both a where clause and a having clause in the same one. In fact, let me just look at this real quick with you. So on the sales order header table, I'm going to come over here and I'm going to add in a where clause. And I'm going to say where, and we're going to do territory ID, right? Now the territory ID that I want to put into my where clause right here when I'm doing the where and the having clause, this is not something I'm doing an aggregation on. I'm not getting the minimum or the maximum or the sum, so therefore it doesn't go into the having clause, right? It goes into the where clause like a normal filter would. 98% of the time, you're going to be working with the where clause. You're very rarely going to use the having clause, and that's just because of the complexity of how you will write SQL statements. But you do write it from time to time like we did here. So I'm going to say where product or territory ID equals 1, execute that code, and this works perfectly. So here it is. Walk with me through this one more time. First, we're getting all the data from sales order header. Then the engine is filtering down and getting rid of all the rows of data that are not territory ID 1. Then it's doing a sum. In fact, you'll notice customer ID 11,000 all the way through 11,011. They apparently never had a transaction in territory ID 1. They do not get returned in the result set. So after all of those rows are filtered out, then we come up here and we select the customer ID, perform the sum, perform the count, and then you'll do like your order by and all of that, right? So this is very, very important to understand. All right. Now you can also have a where clause and a having clause in the same statement. So for example, we have a bunch of customers that have like $89 in sales, $125. If I want to exclude them from the final result set, we can't do that in the where clause. Remember, we do a having clause. Having sum of total due greater than, let's say, 2,500. So I'm going to go under the group by clause here. All right, we're going to go to the group by clause. We're going to say having, right? So having, let's do sum of total due greater than or equal to 2,500. All right. And we'll hit F5 again, and then we come down here, and now we're only getting records where the territory ID is 1, where the total of the sum of the total due is greater than 2,500, customer ID, total sales, total transactions. This is a ton of great information here. This is how you do aggregate queries, group by having, all of that. All right, let me see here. I think we are very close to the end of the day, but I'm going to do one more query here. One more query, and then I'll kind of start doing some wrap up and maybe some final questions here at the end of the day, give you some time back in your day. So the last thing I want to do is, instead of doing a having clause, which we just did, I might also want to do something like a having clause on the count, right? So maybe I don't want only, and I'm doing this a little bit different than what you have in your notes, but maybe I want to do where the total due is greater than 2,500 and the total transactions is greater than 1, right? So think about that for a minute. How would I do that? If I wanted to return only the records down here where the total sales was greater than 2,500 and the total transactions is greater than 1, how would you modify your SQL query to do that? That's the question, right? The way that I would do that is I'll come up here and say and. So this is going to be in the having clause, and, not or, and total, well, we'll type it out. So let's do and count star is greater than 1. We'll go ahead and hit F5, and now we're only getting the records right here where the total is greater than 2,500 and the count is greater than 1. Now see, we're getting all kinds of garbage in the chat window there. All right. So that really brings us to the end of the session today. We got done a few minutes early, answered a ton of questions. Thank you, Manuel, for your help in the chat window. That was awesome. Manuel's going to feed me a few questions over here because I'm not going to be able to go back through it all. What I do want to say as we're wrapping things up, and we'll probably get done here in about 5 or so minutes, is that you have access to the class files. The database and the server you're connecting to is going to be available. I do want to remind you also that for the people who are on this call, that we do have a sale going on and you can purchase our on-demand learning for half price right now. We have 2 awesome classes that dive way deeper into SQL than what I just covered in 3 hours. you get, 20 hours of recorded content with no interruptions whatsoever. And we have a SQL bootcamp that you can join as well. But part of that subscription, we have over 70 classes that talk about Microsoft Azure, Power BI, SQL Server, SSIS, SSAS, just a ton of different things that we've been teaching for many, many years. So it is an incredible value, and we would definitely encourage you to sign up right away. Thank you, everybody, for joining us today. I hope you got the most out of it. Manuel also has a certificate that you can fill out a form for, as well as a survey. We would love to hear from you and hear what you liked, what you didn't like, and what would you like to see from us in the future on our YouTube channel. Let us know and keep us informed. Can we extract the data and export to a CSV file using SQL? That's a good question. I don't know about that one. Can I extract the data using SQL? Not to my knowledge. I don't think I've ever done that. I've done it with R, I've done it with Python. But with SQL, I don't think I think there's a way you could right click down here and you could copy the data. So the easiest way would probably be to come down here, right click, save the results as, or copy data right here in the results set. So if you want to do it, that would probably be the easiest way. Programmatically, probably not. I'd use a tool like SSIS or some kind of ETL tool for that. Yep. All right. So yeah, Melissa said the same thing. Just copy and paste. Good job. Thank you, everybody, for the great comments. Just trying to look through the comments, the questions. Can we pay monthly? Yes. We do have a monthly subscription plan. You can sign up and pay each month individually instead of doing yearly, and you can still get the discount with the monthly subscription. So great question there. Thank you so much. Thank you, Julie. Appreciate that. So there's no major difference. Yeah, so good question. So T-SQL is transact-SQL, and that's the Microsoft flavor of ANSI SQL. But you have T-SQL, which is transact-SQL for Microsoft. You have PL-SQL, which is for Oracle. They all have to adhere to very specific rules. So if you write your code in a specific way, it can actually translate from T-SQL to PL-SQL, no problem. But yeah, T-SQL is Microsoft's flavor. It's kind of like thinking of somebody from America, how we might pronounce things and say things, and somebody from England, right? You can still understand both people if you speak English. There's just maybe an accent there, and there's some differences, yeah. But you'll see SQL in a lot of places. Like when I write notebooks in Azure, there's Spark SQL. When I connect to a Salesforce, there's SOQL. When you actually writing and pulling data from data lake using serverless on demand, you use SQL to do that. So SQL is used in a lot of different places to pull information from that. Adrian, interested in the monthly subscription. Great. I'm happy to hear that. Awesome. Awesome. All right. I think that is going to wrap up the class. I'm going to do a follow-up YouTube video. I'm committed to it. There were a ton of questions. Manuel did a great job. Maybe Manuel will join me and we'll do one together. We'll do a follow-up video where we'll answer a lot of these questions there. So I hope to see you in that follow-up YouTube video. Enjoy the rest of your